Hi everyone, Steve Buchanan here, and welcome to my course, Python for Linux System Administration. I'm a cloud and DevOps architect. This course will teach you how to utilize Python to administer Linux servers. In this course, you will learn the core of the Python language, various Python admin modules, and how to combine Python scripts with other Linux tools for administration. Some of the major topics that we will cover include gaining an understanding of the many benefits of using Python for systems administration, what goes into setting up a Python environment and what IDEs are the best option to assist you with your Python scripting, how to install and use Python to interact with the Linux system, and how to utilize Python modules such as the OS module and psutil to perform various administrative functions. By the end of this course, you will have a better understanding about the core of Python, how it can be used for administration, why you would use it for administration, how to get set up for Python scripting, insight into the Python administrative modules and scripts, as well as some real-world examples of administering Linux servers with Python. Before beginning this course, you should have general knowledge of scripting concepts, system administration, and the Linux operating system. I hope you'll join me on this journey to learn about administrating systems with Python in this Python Linux System Administration course at Pluralsight. Welcome to the Python for Linux System Administration course. My name is Steve Buchanan. I'm a DevOps architect, and I'll be taking you through this course. The first module in this course is titled Python Quick Start. This is a primer to get you going with Python before we dive into administering Linux with Python. Let's take a look at the topics that we'll cover in this module. First, we're going to level set this course, what you can expect from the course, what you can expect, what you should know coming into the course. Then we'll go into an overview of Python. We'll give you the characteristics and features of Python, the many uses of Python today, why you should use Python for system administration, and then we'll do a brief comparison of Bash and Python. Let's take some time now and do some level setting for this course so that we have a good understanding of what you're going to get out of this course and what you're not going to get out of this course as we move through it. So here's what you're going to learn. We're going to give you a high-level overview of Python. So this course is not a deep dive into Python. It's not a programming-focused course on Python. This is going to give you a high-level overview of Python and show you how you can start to use Python for system administration specific to Linux. Now, some of the items can apply across Windows servers as well, and you can take a lot of those skill sets as you move towards things like cloud and maybe even Kubernetes, but we're going to be very focused on Linux. We're going to take you in and show you Python IDEs, how to set up your environment and get started there. And again, this is going to be focused on Linux, but you will be able to take some of those skills that you gain and apply those across other platforms as well. And we're going to go through how to install and use Python on Linux. That's going to be a big one. And then how to use Python for sys administration tasks on Linux. Now, again, some of the things you learn here, the principles, you can take and apply those across, Windows platforms, cloud, etc., etc. Once you learn Python and once you learn how to use Python for administration, you can start to apply those in other areas as well. So in this course, we're going to look at server health, some user and service management, working with files, strings, text, all the basics there, and then combining Python with other tools to help with system administration. Now, if you need to ramp up on Python, there's courses on Pluralsight that I'm going to recommend you go and watch these. Now, there's the Python, the big picture. There's Practical Python for beginners. And then there is the future of Python to give you an idea on where Python is going. So again, we're going to do a high-level overview of Python in this course. You're going to see some code. You're going to see some demos. You're going to have some exercises that you can take and basically use. But if you're brand new to Python, you might want to take a look at some of these other courses. Or if you're looking to build applications, you're going to want to dive into some of the other Python courses that are available on Pluralsight. Now, here's the backstory that we're going to follow for this course. So you're a Linux admin for your company, right? And your department has decided to go ahead and standardize on Python for all scripting, also for your web development. And they want that so that learning efforts can be matched across teams, across environments, and really just to standardize on Python all up. Now, leadership wants the DevOps and SRE engineers, which includes you, right? You're an administrator, to work from the same language for scripting when you're automating things. And so this is going to support a standard of scripting skills, knowledge share across teams, as well as when you hire new engineers, you can just start onboarding them to Python for your administration, or they might come in the door with Python skills and they'll be able to ramp up easier and really hit the ground running in your environment. And the leadership, they want you to learn Python, and they want you to lead the charge of automating your Linux system administration using Python. And so you already have the Linux knowledge. You've been doing Linux for a while, but you need to ramp up on Python as quick as possible. So that's the backstory that we're going to follow as we go through this course. So here are the personas that are best fit for this course. You should either come from a system admin background, a Linux admin background, maybe you're a DevOps engineer or an SRE engineer. And things that are good for you to know, bringing to the table, are scripting concepts, some knowledge of programming. You don't have to be a pure developer, sys administration, and of course, knowledge of Linux. Now, let me give you an overview of Python. So Python is a general purpose programming language. So there's many uses for it. It's very flexible. It was created in 1991 by Guido Rossum, and he now works for Microsoft. It has a very simple syntax that's actually close to the English language, which makes it easy to read and easy to code in. Python is interpreted and it's interactive. So as you're typing code, you can run it right there, or you can have Python scripts. It's cross-platform. So it runs across Windows, Mac, and Linux, but also on Raspberry Pi and other platforms as well. It can be used in a procedural, object-oriented, or even functional way. So again, a lot of flexibility. And the most recent version of Python is Python 3. But is it popular and widely used? Well, it's actually number one on the chart of programming languages out there, with a market share of 29.53%. Now, I've listed the link there so you can check back in the future to see how Python is doing. But as of right now, the trend has it continuing to grab more market share among programming languages. Why is it so popular? It's because it's easy to learn. It's flexible, meaning it can be used for basic tasks or very complex needs. So if you're a beginner programmer or you're just looking to do some sys administration, you can use it for that and get started very easy. Or if you're an advanced developer or you need to do some very advanced system administration tasks, you can also use Python for that. And it's used for many things, from websites to video games to automation and even data science. It's efficient, it's fast, and it's reliable. And it's all of those things across all of the platforms that it can run on. That's why you see devices like Raspberry Pis running Python. It has vast libraries, so it has functions and modules, and those help extend the functionality of what Python can do. And there's a very active and supportive community out there for Python. And so there's forums if you need help. There's folks that are publishing blogs. There's many articles. There's even Python conferences. And there are other sys administrators and developers that are sharing their scripts. And so if you have a need to do something in Python, chances are you can run a quick search and someone's already done that. You can grab the code and reuse that. And then Python has become the go-to academic language. What that means is that as students are going to college, many of the universities are teaching Python as a part of computer science and other tech-related degrees. And those students are coming out of college and going into the workforce, and they already know Python and have experience with it. And so they bring that to the workplace. And it just makes it more attractive and easier for companies to adopt because folks are already coming out of college with the skills. And so all of these reasons and many more show us why Python has become so popular and has become the number one programming language out there. Now let's talk about the characteristics and features of Python. First of all, let's dive into the characteristics. Now, you can run Python in command line. You can also run Python scripts by creating a file with Python code in it, and that's going to end in a .py. There's an example of a file name there. And so when you have those Python scripts, you can call those from a command line to run them, or you can call those in like an automation system. Think of like CI/CD or some other sort of automation system, or even running through a cron job to run against your servers on a schedule. Python uses indentation to indicate blocks of code. So this is critical, and we're going to give you an example of what this looks like. Single line comments start with a hash, and multi-line comments start with the 3 quotation marks and ending with those. So keep that in mind, because I know comments are important when you're writing code and when you're writing scripts. Python can be used for scripting, or it can be compiled into code for building larger applications. And Python has an automatic garbage collection, so it does some cleanup there for you. Now let's look at an example of the indentation. So you can see there, we have our first line of code, and then on our second line of code where we have print, that's where the indentation comes into play. Now, if you don't have this indentation and you go and you try to run Python code, whether it's right in the command line or from a script, it's going to throw an error. So you have to have the indentation in there to indicate your blocks of code. Let's talk about some more characteristics. So Python has a number of built-in functions, and it has a number of built-in modules. If you want to see the list of built-in modules, you can just run the help command there right from your Python, and it'll output a list of the modules that are loaded. Now we're going to take a look at some of the functions and some of the built-in modules that are there. We're going to take a look at a sample of that so you can kind of see what's there in Python. Now, there's a vast library of external modules that are available as well. So if you need to do something that's not included in the built-in functions or modules, you can typically find it in an external module and add that to your Python and then use it in your code. Python has many predefined classes that you can use. You can also define your own classes and start to use those in your code. There's a thriving community for Python. There's forums, there's conferences, podcasts, blogs, many books, training like this. There's a huge community. Also, there's powerful built-in data types for Python to help you as you're working on your administration and you're having to manipulate files and do things with files or even code on your systems, right? There's strings, there's integers, floats, lists, etc., etc. And we're going to go through some of those things as we move through the rest of this course. Now, there's a term called batteries included. You might have heard it. When folks say that or reference that in blogs or even books, what they mean is the built-in modules that come with Python. Now, there's a large collection of these modules, and when you install Python, they're already there. And there's a huge library of additional modules that are available for Python, and there's 2 links there that you can use to search for those. So you can go out and you can use the PyPy to get packages for Python, or you can visit the docs.python.org link there to see an index of the modules that are available. Now here's a sample of modules that are available for Python, and we just want to take a look at this. I'm not going to drain or talk about each one of these. I'm just going to call out some specific ones. So you have the math module that gives you the capabilities to perform math functionality in your code as needed. You have string, and that's useful for working with different strings in your code. You have gzip, so you can read and write and work with compressed files. You have tar file, so that works with tar archives. You also have OS, and we're going to reference this throughout the course. You're going to see this. This allows you to work with the operating system. So this is heavily used from a sys administrative perspective. And then you also have sys, which is similar for sys administration, very useful. You have HTTP, which helps when working with web apps. So if you're running web servers and you're administering those, it'll help with that. You have logging, and that helps with working with logs and doing automation there as well. Now, this is just a sample of the modules. There's a huge list out there, and I'd recommend that you go out to the module index and check that out or run the help command. Now, here's another example of Python code, and this is just showing you that you can run the Python code right in the command line itself. And so this is an example of simply doing a print of hello world. And so pretty straightforward there. Now let's talk about the common features of Python. So Python is easy to learn, right? So practically anyone can pick up Python and learn how to code, and you can do this in just a few hours or even a few days versus weeks and months. You can really start to program and even automate from a sysadmin perspective, very easy things in just an hour or two after learning a little bit of Python and working with it. It's very easy to read and very easy to code in. And that's what makes it easy to learn, right? So Python's code is clearly defined and it's very close to the English language, making it really easy to read and be able to program in. And it's easy to maintain. So many source control systems have direct support for Python, and its source code is fairly easy to maintain in those source control systems. It has a robust standard library, and we talked about that a few times already. And so this library has modules and even functions in it that allows you to do things like manipulate images, work with databases, and much more. Python has interfaces to all the major databases. So many applications use databases on the back end, and even with administration, you may have a list that you want to store in a database and you might want to pull from that list. Right? Think about if you have a list of servers or maybe you got an IP management system and you want to be able to pull from that data and then perform some sort of automation against your servers or in your environment from that. Well, Python has interfaces to connect to those databases. It's portable, so you can run it on a wide variety of hardware platforms as well as operating systems, including Linux, Windows, and many more. And it's extendable. So you can take and you can write some Python code in C or C++, and you can compile that code. You can go ahead and take Python and extend it if you want to. You can even create other tools based on Python. For example, Ansible and Salt were both built on Python. It's easy to debug. You can quickly identify and correct a majority of the program's issues just looking at Python's errors. And it's scalable, right? So Python's structure and support for large programs make it really easy to scale when you need to scale if you have complex or big automations. And also you can write GUI interfaces for your Python programs. And so as you're writing your system administration automation, let's say you want to make an automation available to junior administrators or programmers or even business users, you can create a GUI, and maybe that's an interface like a form that person would fill out, and then that would fire off an automation. You can do that with Python, and there's a bunch of different modules that are available to help you with that. Now, the last thing is I want to talk about Python's versions. Right? So the major versions are version 2 and version 3. And these are the versions that are out there. You'll see them in the wild. You'll see them being used in environments. And version 3 is the latest and greatest. And that's what we recommend that you utilize. And that's what we're going to focus on in this course. But just keep in mind that version 2 is out there. It's still supported. There just isn't new development going into it. But many environments are still using version 2. Now, the other thing is that version 3 is not backwards compatible to version 2. So keep that in mind that you either go with one or the other. Let's dive in and explore the many uses for Python. So Python is used for many different things across many different companies, and we'll just kind of go through the list here. So of course, you can use Python for system administration and configuration management. Now, I have Python and Ansible listed there. The reason why is because you can just use pure Python for your system administration, or another common tool is Ansible. And Ansible's listed there because it was written in Python. And so under the hood, you're actually using Python when you're using Ansible. In fact, one of the requirements of Ansible is to have Python enabled on the nodes that you're managing. Another one is AI and machine learning. Now, you'll notice in parentheses, I have a couple of modules listed there. And those are common modules that are loaded into Python to help with AI and machine learning. And you'll see that through the rest of the items here. And then, of course, web development. This is a big one. You have things like Django, Flask, and others there. And those are web frameworks specifically for Python. Now, there's a lot of very popular, heavily used websites and web apps that have been developed in Python. And we're actually going to take a look at a few of those. Game development. So yes, you can create games with Python. Data science and data analytics are huge areas of use for Python. And there are common modules there that help enable and extend Python for data science and data analytics. And then we have network automation. And again, Ansible's listed there, Tornado, Twisted. You also could put Salt in there. And you could actually put Salt in system administration and config management as well. And Salt is another common sysadmin, config management, DevOps tool that's heavily used in environments today. And it's often used with network automation as well. And the reason I bring up Salt is because it was also written on top of Python. And so Python is powering that tool as well. Web scraping, and then desktop GUI-based apps can also be built with Python. And you'll notice the modules there that are common for building those GUI applications with Python. And then another one that might not be as commonly known is you can actually use Python for managing your multiple clouds. So your top three like Azure, AWS, and GCP, and even Kubernetes, right? There are modules in Python for all of these clouds and Kubernetes clusters. And so you can see a theme here that Python is a very flexible language, and it truly is general purpose and can be used for many different things. The key to this is it's very modular, and there's a lot of modules out there that you can add into Python to help extend to many platforms and different types of uses. Now let's take a look at who's actually using Python out there in the wild and what apps and websites are built with Python. So Netflix is leveraging Python. Ansible and Salt, those are common tools in the DevOps and system engineering world. Instagram was built on Python. YouTube is built on Python. And even OpenStack. So OpenStack is a cloud system, so you can enable your own cloud on premises. And the entire system was built on Python. I'm sure there's some other languages mixed in there too, but it's based on Python. And it's using Python to do network management, manage servers, etc., right? So Python is a very powerful language, so powerful that an entire cloud management system for your on-premises hybrid cloud and private cloud was built using Python. And then Google.com is using Python. Dropbox has Python. And Blender. Blender is an actual application. It's not a website. Blender is a 3D app animation tool that's open source that can be used to create 3D animations, and it was built on Python. And then here's another big website, Quora, that was built on Python. As you can see here, there's a lot of well-known names and heavily used web apps or applications that were all built on Python. And so there's a great selection out there and some really good examples of what you can do with Python. Let's take some time now and explore why Python is a good choice for system administration. So we're currently in the age of DevOps, and this is forever transforming, but there's a huge emphasis on being able to automate both simple and complex administrative tasks in your environments. Now, with something like Python, there's a small learning curve to getting up to speed on the language, and the code is very readable and easy to start writing scripts and automation in. And it can help with your system administration. Now, with Python, there's actually a large pool of sysadmin related modules that are out there available for you to utilize. And there's also even built-in modules that come right in Python that can help with your system administration. So this positions Python in a really good place as a great language and tool for helping you with your DevOps and your system administration. Now, typically with Linux administration, we have a bunch of tools that we lean on to help us with our automation and our administration in general. And this is a list of some of the tools that are there. We've already touched on Bash a little bit. We often use sed for replacing text in files and grep for finding text in files. And so you have all these tools, and you can take something like Python and consolidate into one tool and one language, getting you to a place where you can be standardized and centralized on a language and a tool across all of your servers and your environment. Now let's look at more reasons why Python's good for system administration. First one is it's already out there being used by system administrators as well as DevOps engineers. So Python for system administration has a proven track record. Also, if you're using Bash, you're going to run into a time where using the shell just doesn't meet your complexity needs, right? And that's where something like Python can step in. It's cross-platform, so it supports a wide variety of Linux distros as well as other operating systems. You can run Linux shell commands in Python with the OS module. So if you have Linux shell commands that you still need to run for whatever reason, you could do that in Python as well. And then there's Ansible and Salt, which are widely used by DevOps engineers and system administrators. And both of those were written on Python. And again, those are already widely used out there in production environments today. And by moving to something like Python, you can go ahead and consolidate from many tools and languages into one tool and language and help standardize there. Now, Python has a built-in module that can perform networking tasks. So you can go beyond just the server administration and you can start to automate your networking as well on the servers, as well as you can actually automate networking with, many of your networking devices as well. And then you can automate the process of logging, and you can use Python beyond server management. Python actually has modules for all of the 3 major clouds, and it has a module for Kubernetes as well. Let's dive into a comparison of Bash and Python. So let's look at the tools first. With Bash, it's a Linux shell and language that's great for writing shell scripts. It's in a command line interface, and it's really great for simple automations of code that are 100 lines or less. It's also good when you don't need debugging or have advanced functions that you need to perform with these scripts. Python, on the other hand, is a cross-platform, general-purpose, multi-paradigm programming language. And it can be used to automate any simple tasks or even complex tasks. It's widely used in many environments for many things. Now, Python comes with built-in functions and modules, and it has additional modules that you can go ahead and add to get the functionality that you may need. Now let's look at some code from both Bash and Python. And in this example, we're going to look at code that'll tell us if a file exists. So on the Bash side, you could see there, we're specifying that we're looking for the host file. And if Bash finds it, it's going to echo host file exists. If it doesn't find it, then it's going to echo that host does not exist. Pretty simple. On the Python side, we have to import a module first, and we're importing the OS module. And then we're looking for that host file to see if it exists. If it does exist, then it's going to print that the file exists. If it doesn't exist, then it's going to print that it doesn't exist. So you can see that the syntax between these two are somewhat similar. There's a little bit more involved with Python to accomplish the same task, but it's pretty straightforward as well. Now in this next example, we're going to look at using both Bash and Python to read a file line by line. So on the Bash side, we specify the file that we want to read. And then we do a while loop where we're reading line by line. And we have an echo to output the lines as it's going through. And then it will stop when it's done, when it's read all the lines. On the Python side, we are opening the file and we are specifying that it is file. That could be anything. It could be book list or it could be file 1. And then we're running a for loop to read line by line in file. And then we're printing that output to the screen line by line, and we're stripping the space in between the lines that would normally be there. And so you could see on the Python side, there's actually slightly less syntax that we needed to accomplish the same thing of reading a file line by line compared to on Bash. Now here's a list of the core differences between Bash and Python. And we'll just kind of run through some of the key points here. And so we've already talked about what the tools are, what they're designed for. So Bash is really designed for interpreting user commands and automating tasks. Python was specifically designed for web and app development, and it's such a good language for general purposes that it's been used for automation and many other things, such as even in data science. Now, Bash is good for small and simple scripts, and it's good for automation on Linux systems. Python is better when you have larger needs or more complex tasks. Example, a good benchmark is that if you have something that's going to take more than 100 lines of code, you'll probably want to use Python. Or if you have something that needs to be automated across multiple systems, being Linux servers, or even a mix of Linux and Windows servers, you can utilize Python. Now, from a simplicity standpoint, most Linux admins are already familiar with Bash. And for simpler scripts, Bash is a great option. For scripts that require more code or have more complexity to them, Python's going to be a good option. And then for maintainability, it's harder to maintain Bash scripts. And Bash doesn't have any debugging tools native in it. On the Python side, it's easier to maintain than Bash in your source control systems. Also, Python has debugging capabilities and better error handling compared to Bash. Now, from an availability standpoint, Bash is installed by default on all Linux distros. On the Python side, some Linux distros are coming with Python installed, but not all. Also, if you need additional functionality, you'll have to add additional modules to Python to get that additional functionality you might need to automate things in your environment. Now, something else to keep in mind as far as availability, you can use Python across many platforms, and you can even use it against things like networking devices. So from an availability perspective, it's going to have a wider range. Now, when we talk about performance, this really depends on a lot of different variables in your environment, what you're doing with the script, how you're running the scripts. And so take this one with a grain of salt, but typically Bash has really good startup times and Python is really good as far as execution times. Now, with that being said, keep in mind, there's a lot of variables that are at play that are going to enhance performance as needed. So to sum this up, both Bash and Python are common tools. They're used widely for administration and automation. They're used by DevOps engineers and sysadmins out there. And it really can become difficult to select one over the other for your admin and your automation needs. The net is that it really depends. And what you want to do is you want to look at the task, the scope, the complexity of the task that you need to automate, and take all of that into consideration when you're deciding, do I use Bash or do I use Python? Or maybe you're going to use both. Or maybe you'll decide to use Python and you'll just run shell scripts inside of Python where it's needed or where you think it's a good idea. Let's recap what we learned in this module. In this module, we covered the following. We level set what you can expect to get out of this course and what knowledge you should come armed with to get the most out of this course. We then looked at what Python is, some of the websites and apps that have been built with Python. We looked at its characteristics and features, as well as the many uses of Python today. And then we looked at why Python should be considered for sysadministration. And we also did a brief comparison of Bash and Python. All of this is important because as you move through the remainder of this course, The information that you gained in this module around Python is going to support you and become a foundation as you move through this course, and it's going to help you understand the value that Python brings to system administration. Welcome to the Creating a Productive Python Environment module. My name is Steve Buchanan, a DevOps architect, and I'll be taking you through this module. Here's what we'll be covering as a part of this module. We're going to look at setting up your environment to get ready for Python scripting and Python authoring. We're then going to take a look at the standard Python interpreter, and then we're going to look at something called IPython, an enhanced interpreter. And then we'll move on to talking about integrated development environments, also referred to as IDEs. Specifically, we're going to look at IDLE. We're then going to look at PyCharm. And then we'll finish off by taking a look at VS Code. And we're going to look at using all three of these as your IDE for Python. Let's spend some time now discussing our environment setup for Python. Now, there's some general setup and configuration that you're going to want to do for your Python environment before you start administering your Linux environments. So the first things first, you want to make sure Python is installed. Now, that's a given, but it's something that we should definitely mention. And we're going to cover that in more detail in the next module in regards to installing Python on Linux. The next thing is you're going to want to make sure that your system path is set correctly. And when Python is installed, this typically is done for you. Now, it's good to double check and make sure everything is set. So we have Linux listed there, and we also have Windows listed there. And so that's where your system path is going to be for Python. The reason we have Windows listed there is because you might install and set up your Python environment on your local machine, and that could be a Windows box, and you'll be connecting to your Linux servers. That's actually a common setup and a common configuration. Now, you might be working from a Linux machine and connecting to Linux servers, or you might even be working from Linux servers directly. Then you'll want to select your interpreter for Python. And you could go with the basic interpreter, or you could go with something called IPython. And we'll cover that in this module in just a little while. But basically, when you pull open a terminal and you type in Python, now you're in the interpreter. And there's some differences there between the basic and the enhanced interpreter. And typically, as a DevOps person or a sysadmin, you're going to want an IDE, which stands for Integrated Development Environment. You're going to want an IDE to use for your Python scripting. Now, an IDE is a development environment typically for developers. Now, don't let the word developers there turn you off from using an IDE, because most sysadmins and DevOps folks use IDEs. Now, what IDEs are is they have features and functionality specific for a certain language. And we're going to cover IDEs in regards to Python later on in this module as well. And then you'll want to install your packages and or import your modules. Now, keep in mind that you're not going to know everything you're going to need up front. And so you will end up installing packages and importing modules later. And typically you import your modules in your scripts, but you also might use them real time when you're just working with Python right from the interpreter. And so for installing packages, you use pip, and for importing modules, you use import. And again, we're going to cover both of these in more detail as we move along. And then you want to select your location. So I touched on this a little bit when I talked about the system path, but you could basically have your environment running on your local computer. You could have it running on a server like a Jumpbox or the server you're going to administer. You could have virtual environments set up, and we're going to talk about those. But it's good to understand where you're going to have your environment, where you're going to do your Python scripting from, have that selected, and kind of understand what you're going to need and how you're going to connect to that. And then last but least, as you're working through different projects or administrative tasks, you'll want to set up a project for these things. And that's going to be basically a folder. And then you'll put your scripts. You might even choose to do a virtual environment, and you kind of group everything together in that folder. Now, let's talk about importing Python modules, right? So a Python module is basically a file with a .py extension, and a package is going to be a collection of those Python modules. Now, to import a Python module, you would just run import space, whatever that module name is, from your Python interpreter. And so in the example syntax there, we have import time. And installing packages is typically done using pip. Now, that's the most popular tool for installing Python packages. There are some others out there, but pip typically comes with your Python install. Now, sometimes it's not installed automatically, and you'll have to install it yourself. And we'll look at the syntax for that in just a second. But what pip does is it basically helps you find, download, and install packages from PyPy or other Python package indexes. And so pip is a really good tool to have in your tool belt, and you'll want to familiarize yourself with it. Now, in our syntax there, to install a package using pip, you'll want to run pip space install space psutil. And psutil in this example is the Python package that we're talking about. Now, you can see the syntax there for upgrading psutil using pip. You can also see the syntax there for uninstalling psutil using pip. And then the last syntax there is really good for you to have, and that can be used to show a list of installed Python packages that are currently installed on your machine that you're working from. So to do that, you just run pip space list, and that will output the list of packages that are installed for Python. Now let's talk about Python virtual environments. A virtual environment basically allows you to have Python packages installed in an isolated location for a particular task, or if you're developing an application, for example, for a specific application, and it's not available globally. Those packages are not available globally in that instance. And so it's really good from a isolation and separation perspective if you don't want things to overlap or maybe even conflict, right? And the two top common tools used for creating Python virtual environments are venv and conda. Now, here's the syntax for creating a virtual environment using venv and Python 3. You basically run Python 3 space -m space venv and then your directory name, whatever you want to call that virtual environment. And after you do that, then you can start to develop your scripts and or application in that virtual environment. You can start to install packages in that virtual environment, and things can be isolated. Now let's talk about Python development environments, right? So first things first, we need to talk about the Python interpreters. Now, out of the box with Python, you have an interpreter, okay? And the interpreter lets you type in Python code, and it gives you results right in the shell, right in the terminal. So you can run the Python interpreter from any terminal on your Linux server. Now, to create and basically edit scripts, you would typically use like a text editor, right? You can't edit your scripts per se in the Python interpreter itself. Now, there's something called IPython, and this is an enhanced interpreter, and we're going to cover this in more detail, but it adds additional functionality on top of what you have with the Python interpreter. And then you have something called IDLE, and IDLE is basically a minimal integrated environment, so it definitely falls short of a full IDE. And then you have something called PyCharm, and we're going to talk about IDLE, PyCharm, and PyCharm is a fully integrated environment. So it's a full-blown IDE and full-blown first-class support for Python. And then you have VS Code, and VS Code gives you an IDE for Python, and it does that by loading an extension for Python into your VS Code. In fact, there's actually many Python extensions for VS Code. And again, we're going to talk about the interpreters, and we're going to talk about these IDEs in greater detail. Let's take some time now and let's dive into the Python interpreters. And we're going to talk about the standard Python interpreter first, and then we'll talk about the enhanced Python interpreter. So what is a Python interpreter? It basically takes code that a user puts in the terminal that's in Python, the Python language, and it's going to convert that into a language that the system can understand. Now, the Python interpreter is reading and executing your code instantly. And so it's doing this in interactive sessions. But you can also put your code in .py files, and those are basically Python scripts, and those can be run from the interpreter as well. Also, you can pre-compile code, so write full applications, right, with Python, and those can be run from Python interpreters as well. And the Python scripts are either in Python, or Python 3. What the Python interpreter is doing under the hood is it's reading the commands that are coming in, it's evaluating those commands, and then it's printing results if there are results to print, and then it'll go back through and loop through the code again to see if there's more commands that are being provided to it. And so this is known as REPL. And so the Python interpreter is often referred to as REPL, and REPL in the context of Python is often referred to as the interpreter. Now, what REPL is doing is it's reading input, it's evaluating that input, so set of commands, and it's printing results, and then it's going to go ahead and loop back through if it needs to loop back through. And that's what REPL is. Now, let's summarize the Python interpreter. So with the Python interpreter, basically, you run Python from a terminal, and you're in the Python interpreter, and then you can run your code, and it's going to read, evaluate, and then print results, right? So that's the interpreter. If you're going to write Python scripts, you're basically using a text editor to do that. And so REPL, aka Python interpreter, is useful for real-time results as well as testing. So if you're just trying to do something on the fly, if you're on your Linux server and you need to do some stuff really quick and you want to use Python, you can go ahead and do that real time in the Python interpreter. Now, the basic interpreter supports 4 basic data types: string, integer, float, and Boolean. Now, the enhanced interpreter is going to support that as well, but there's going to be some enhanced things that you're going to see that are supported with the enhanced interpreter. And the Python interpreter, like the standard Python interpreter, is really good for creating and running standalone scripts. Now, let's take a look at the enhanced interpreter, which is called IPython. So as you're working with Python and you're using the Python interpreter, right, the basic one, this can sometimes not fulfill the needs that you need to do, or you just need more functionality. And this is where the enhanced interpreter called IPython comes into play. And you can actually install IPython on Linux servers using apt-get install IPython. Now, that's for Linux servers only, and that's for a specific flavor. So if you want to install this on like Windows or your local machine, it might look a little different, and you'll have to go look that up. Now, after you install IPython, you could basically type IPython in any terminal on your Linux server, and it's going to launch you into the IPython interpreter. So IPython acts as a bridge between Python and Bash. And it does this by giving you some functionality to allow you to run shell commands that you might be used to in Python. And I'll get into that. But before we do, let's cover some additional functionality that IPython brings to the table. So IPython gives you something called tab completion. So as you're writing your code, it's aware of the syntax, and you can actually hit tab to complete the code that you're writing. You also have something called macros, and macros acts like functions in other scripting or programming languages. And so you can actually take a block or section of Python code, and you can make it a macro, so you're giving it a name, and you can actually run that over and over and over. You can run it from other sections of your code, and so it's essentially a function. You also have some interactive debugging capability in IPython, and so you could start to do debugging with IPython. Now, it's not going to be as robust as what you're going to see with full-blown IDEs, but it's a very good start. And then you have something called profiles. And profiles are basically directories, and they contain things like your configuration, your runtime files, and even things like logs and connection info, and even IPython command history. And so you can use profiles to kind of separate out between projects or administrative tasks that you're doing, and you could preload these to bring you back to where you were. It's kind of like a marker to get back to where you were so you could continue where you left off. And then you have something called magic commands, and these are basically enhanced commands over the normal Python code. And these start with a %, and they basically can do more than what you can do with a Python code. And this is where that bridge between Bash and Python starts to come in, because you can run shell-like commands using the magic commands. So you can see there, we could actually run our working directory with the %pwd, or we could go ahead and change directories in the IPython interpreter using the %cd. And we can't do that with the standard basic out-of-the-box Python interpreter. Now, there's a bunch of built-in magic commands, and you'll want to go to the Python site and familiarize yourself with the magic commands that are there. And you could also create your own magic commands via alias, and we'll talk about that in a second here. You also can run .ipy files, and these are Python scripts. You can run those from IPython, and within those .ipy files, you can have magic commands, and you can also have shell commands in those scripts. So with your .py files, you don't have that capability to be able to run those magic commands or those shell commands. So that's another enhancement that you get with IPython, and another way that you're bringing in those magic commands and having a bridge between Bash and Python. You also can run some shell commands because you have system shell access right from IPython using the exclamation mark in front of those commands. So for example, there you can run an ls to list the contents of a directory right from IPython, and you can't do that from the standard out-of-the-box Python interpreter. And then last but not least is aliases. And I kind of mentioned that, but with aliases, basically you can go ahead and create aliases for commands or syntax and go ahead and run that from IPython. And so we could actually create aliases for certain shell commands, or we could create aliases for, Python code that we've written, and we can use that to call it and shorten things and make things more efficient and easier. So now let's go through a summary of IPython, of what we covered here. So IPython is actually highly configurable, right? But it does fall short of a full-blown IDE. But you can use some things like aliases. You can create your own magic commands. You also have profiles. And so you can start to configure IPython for your specific needs. It's easier to navigate in, right? So you can do things like use certain bash/shell commands, right? Like clear. You also could run an ls with the exclamation mark in front of it, and you can access some additional shell commands, right? So it's a little bit easier to navigate in, and you can't do that with the standard Python interpreter. You have access to shell commands, and I've mentioned that, several times, and this is really, really powerful, especially if you're moving from using Bash to Python. This gives you that bridge between the two, and help support you as you make that transition. And again, IPython supports .py files, but it also supports .ipy files for scripts. And so it's going to give you enhanced capability there because it's going to give you access to the IPython scripts, where the standard Python interpreter is not going to give you that. So that wraps up our IPython and the enhanced capabilities. And we're going to take some time in this module to actually look at both of the interpreters. This demo, we're going to look at using the default Python interpreter that's there with Python out of the box and compare that to the IPython interpreter that you can load. Let's dive in. Okay, now I'm connected to my Linux server here, and I have a Bash terminal open, and I'm going to do a comparison, just kind of show you the differences between the basic Python interpreter as well as IPython. So let's go ahead and get started. So the first thing we need to do from the terminal here is go ahead and type Python. And we need to make sure we're clicked in the terminal. And then from there, let's just do a very simple thing. Let's just print, right? Some syntax here. So we'll do Python course. Really simple, right? Just giving us an output. Now let's do something a little bit more complicated. So we're going to do a variable in Python here, right? Using an input. So what is your name? Okay, so now it prompted me for my name. So we'll just type in Steve. Okay, so now we've stored my name in a variable. The variable is called name. And let's go ahead and see if we can print that. Now I'm hitting the tab key, and notice like it's not auto completing, right? I just wanted to call that out. And so there it is. So it outputted that for us. So now let's show something else. Let's go ahead and import a module here. So we're going to import the OS module, and then let's just show the operating system here. So there we go. Pretty straightforward, pretty simple. A couple of things I want to point out too. So I'm going to run an ls. I get an error. I'm going to run a print working directory. I get an error there. I'm going to try to run a cd, right? I'm getting an error because the basic Python interpreter does not know how to work with these shell commands. It just doesn't. It wasn't built that way, not designed that way. So I've imported the OS module. I can actually go ahead and print the working directory using that. Let me back up here and fix my syntax. And so there it is. So that is the equivalent of a print working directory. But I had to import a module in order to go ahead and, get the working directory. So that's the basic Python interpreter. So another thing I want to show you here, I can't clear the screen, like it just errors out on me. So I'm actually going to exit here. And so now we are back at our regular shell. We'll clear that. So now let's go into IPython, the advanced editor. So now we're in here. Let's just run through, the commands, the syntax that we had before. And so we'll just do some basic things here. Something I want you to take note of right away is you could see, right, different colors. So there's color coding there. Also watch this. So we can clear the screen. So you could see here, we're starting to get some of these shell commands that we're used to. Like I can run an ls here. I could even run a print working directory there. So you could kind of see that, right? Now let's do the variable thing, and notice it shows it because it's has it in the history of the terminal here. So I can actually do an auto completion. It sees it. So I'm going to hit my arrow key, my right arrow key to complete that. And then I can run that and it's prompting for what is my name. Okay. And then let's just do a print and we'll go ahead and print that variable. And there it is. Again, it's pulling that from the history. And so can print that. Take note again, right? The colorization in the terminal here in IPython. So it's just a little bit easier to work with and understand, what you have here and what you're actually working with. Now let's do something else. Let's go ahead and import psutil, and it has that there. So let's make sure that's imported. Okay, cool. Now let's see if we can actually print here something from psutil. So I'm going to use my auto completion, and there's my disk usage, right? And so now I want to show you another example of the auto completion. So let's make sure we have the OS module imported here. Okay, we're going to show something slightly different with the auto completion and another way that this functions. So we go U and then we hit the tab key, and you can see it's giving us other options here. So I can hit the down arrow and I could actually, move through these different options. So let's pick U time and let's see if that will give us the results that we want, showing us the time. And it gave us an error, and that's okay. I was really just trying to show you there that you could use this, right, to tab through these different functions and use this to quickly get there, right? So if we run that, it's going to give us the name for the operating system that we're running here. So that's an example of looking at the Python basic standard interpreter, as well as looking at the IPython enhanced interpreter and what the differences are, and just showing you kind of the benefits of using IPython over the standard Python interpreter. Now let's dive into integrated development environments. So again, integrated development environments are often referred to as IDEs, but what are they? An IDE is basically software that's made for developers and that's used to build applications. Now again, that doesn't mean IDEs are not for sysadmins or DevOps folks or cloud administrators. IDEs are for anyone, and IDEs are focused around languages and a set of common developer tools, and it's bringing those things together into a GUI and a tool that can be used to work with that language and or work with specific tools that you might need. Now, typically IDEs will have a source code editor, they'll have a terminal, and so in the context of Python, we have a terminal available for Python, and some of the Python IDEs will even have like IPython terminals, has tools for building automation, tools for debugging, and tools for connecting to source control systems. So for example, in the context of Python, we might want to store all of our Python code on GitHub, and we want to access that from our IDE. Well, many of the IDEs out there have that capability where they integrate directly with Git and integrate directly with tools like GitHub. Now, what are the top 5 IDEs? I think it's important to kind of look at this data to understand where they stand and where other developers, sysadmins, and DevOps folks are using IDEs out there in the wild. And so number 1 is Visual Studio, but number 2 is VS Code, and that's one that we're going to cover in this module here. And then also take note that PyCharm is also in the top 5. And so PyCharm has very robust features and functionality for Python. And so it's important, I think, know this and know that when you're selecting your IDE, what other developers and DevOps folks and sysadmins out there are selecting and what they're using as well. And to know that you're not alone, and also to know that there's wide support and wide adoption for the IDE that you might choose. Now let's explore some of the various IDEs available for Python. And we're going to start with IDLE. So IDLE is an integrated development environment. It's built specifically for Python. It comes bundled with your Python installation, and it automatically starts the Python shell when you open it. To start a new Python file, you basically can click File from the menu within IDLE, and you can click New File from the menu bar, and then you can start to build out your Python script from there. And then if you want to open an existing Python script, you basically do the same thing by clicking on File on the menu, find your file, and go ahead and open it. And then you can actually execute files in IDLE by simply pressing on the F5 key to run the Python script. So it's pretty straightforward. Now, some additional features about IDLE. It was coded 100% in Python. So it was built for Python, it's coded in Python, and it's actually built using the tkinter kit that's used for building GUIs with Python. It is cross-platform, so it'll work on your Windows machines, your Mac OS, or your Linux machines, so pretty much work anywhere. And the Python shell, the interpreter, has colorizing of code for input, output, and error messages. So that helps when you're writing code just to kind of see the differences there and easily tell what's what. And you don't have that in a typical interpreter, but you have that in IDLE. And then you can also have multi-window text editor with multiple undo. You have the colorizing again. You have automatic indentation. And so with Python, right, that indentation is critical. So IDLE is going to help you by doing that for you. And it also has auto completion features in it as well. So it'll autocomplete some of the code as you're starting to type Python code. You can also search within any window. You can do replaces within any window, and you can search through multiple files with it. So it's very helpful from that perspective. Also, you can use it to start doing some debugging, right? And so this is a great way to kind of get started with that. And if you're just starting out with Python, and you don't really feel like installing any other third-party IDE, this is bundled right with Python, so you could just start using it right away. Now, here's a summary of IDLE, right? It's bundled with Python, so that makes it easy. It's a great starter IDE for Python, and so it's already there. You can start using it, start to get your feet wet with an IDE. It has some cool features in it, right? From the command window and the editor window. Completion of your code, that auto indentation is really, really good. And then the colorization of your code between input, output, and errors, so you can see what's what, is super helpful. And also, it's a great tool just to get started with debugging your code. Let's talk about PyCharm as a Python IDE now. So PyCharm is a full-blown IDE. It has two versions, a community version as well as a professional version. And the community version is completely free. The professional version you have to pay for, but it gives you additional features and functionality. Now, it is cross-platform, so you can pretty much run it on Windows, Mac, or even Linux. It's got intelligent code completion in it. And so as you're typing code, it will go ahead and complete the code for you if it picks up on what you're typing. And in addition to supporting Python as a language, it supports a ton of additional languages here too. You can see some very popular ones like JavaScript, HTML, CSS, SQL, and more. So if you start using PyCharm for your Python IDE and you're working in other languages as well, you can go ahead and utilize it for multiple languages from one single tool. It does integrate with source control systems, and so Git, as well as others. I know Git is the most popular, most widely adopted at this point. And so it could integrate with things like GitHub, or if you're using Azure DevOps, or if you're using something else, it integrates with that. It does have robust debugging, testing, and profiling built into it. So this is going to give you the full-blown capabilities compared to something like IDLE, where it's going to be limited as far as what it can do with debugging. It doesn't really have profiling and whatnot, but you get that with this PyCharm here. And then it also gives you on-the-fly error highlighting. So as you're typing your Python code, you're building your scripts. If you are writing code that has errors in it, it's going to highlight that for you so you can go ahead and fix it on the fly. Or if it's, let's say, earlier in the code and you're further down in your code, you'll see that highlighted so you can quickly get back to it and go ahead and fix whatever those errors are that you have. And then it also has database tools built into it, so you can access your databases right from the IDE. So if you think about, working with SQL or something like MySQL, you don't necessarily have to go get the tools that come with those database platforms to connect to those databases. You can actually do that from this IDE and work with those databases. And then it also has another great feature. It's this live editing preview. So as you're writing your Python code, and this really applies more so to like web development with Python, but as you're writing your code, you can actually see real-time changes in the browser. But where this comes in handy from a sysadmin/DevOps perspective is if you're writing, like, let's say, a web-based interface for some of your administrative tasks, right, for other users to be able to kick things off across your servers, you might be doing that as like a little web form. And so you can actually use PyCharm to help with that and see those real-time changes in the browser as you're developing. Now let's talk about the features specifically for Python in PyCharm. And I will say that this is probably the best IDE out there for Python. It's going to give you a full set and full capabilities that you will be looking for Python. Now, here's the list. I'm not going to drain this list here, but I'm going to highlight some critical ones here. So, of course, it's Python aware, right? It has an interactive REPL right in the IDE console. So what that means is you can go ahead and open up a terminal, and as you're typing Python code, you can run it, and it will be very, very interactive, right? It also supports multiple interpreters. So it supports that Python, that basic standard. It also supports the IPython interpreter for you. So if you loaded IPython, you can actually use PyCharm to work with IPython. It's also, giving you completion of your code, like your Python code. It's giving you inspections on the fly. From a debugging and testing perspective, right? It's got a graphical interface. And so it just makes that testing easier to kind of work with. It also is aware of Python, right? So it's going to give you syntax highlighting and checking on the fly. And also it has built-in support for many Python libraries. A few listed there are NumPy, Pandas, and there's many more. And another big one is it supports virtual environment integration for Python. So as you're starting a new project in PyCharm, you can actually tell it, hey, I want to use venv for my virtual environment, or I want to use Conda. Go ahead and set up this virtual environment and store everything there. And it does it through the graphical interface, making it a lot easier to just get that started at the beginning of your Python project. So here's a summary of PyCharm, right? So it's project-based, it's fully integrated with Python, works very well, has 2 editions, so you can go ahead and get started with it using the community edition. If you like it, if it's working for your sysadmin and helping you with Python, you can go ahead and buy the professional edition, or you could continue to use the community edition forever. It's got first-class support for Python, and this thing was really built for Python, and they're always updating it, so it's really good from that perspective. It's got the code completion, code refactoring, and it's just a full IDE, right? And so it's going to give you those things like the on-the-fly error checking, and it's got the graphical interface for debugging and testing. And so this is going to give you a really great experience when you're having to work with Python, when you're writing Python scripts, if you're building graphical interfaces on your Python scripts, or if you're building web-based interfaces for your Python scripts, it's going to support all of that. And so it's a really great tool that you should consider using as you get deeper and deeper into Python for your administration of your Linux servers. Now let's explore VS Code as your Python IDE. Now, before we get into what VS Code is, you're probably asking yourself, what about Visual Studio? Well, Visual Studio does technically support Python, yes. And it does this through an open source support, basically extension for Python. Now, most people these days are using VS Code. It's very lightweight. It's really easy to use, especially if you're a sysadmin or you're a DevOps person. And the Python capabilities in VS Code are very robust from a Python perspective. Now, if you're a full-blown developer, you're probably going to go with Visual Studio because it's going to give you that full-blown developer experience. Also, it's going to depend on what other languages you're working in. But we're going to go with VS Code for the context of this course. And I'm a Microsoft guy. There's no secret there. I've used VS Code for all of my coding needs, and I also use it for Python as well. And so it's very good from a DevOps and sysadmin perspective to really help you and just be lightweight and help you get started there. So VS Code is built on Electron. So it's portable, it's lightweight, it's pretty fast. It is a full-featured code editor, and it does support cross-platform, so it can run on Windows, Linux, Mac OS. We're going to show you VS Code running on Linux in this course, and so you're going to see what that looks like. It's very lightweight, and so you can actually use VS Code in the browser as well. So let's say if you had Python code in GitHub, you could actually edit that Python code right in the browser with a web-based version of VS Code and work on your code right there. It is open source, so this is a Microsoft tool, but it's open source, so it's completely free. There actually isn't a paid version, just the open source version. You can extend it, you can customize it, you can configure it to your needs. There's a ton of extensions out there for it, and so that's why it has wide adoption at this point. It does have terminals in it, and so you can utilize, the Python interpreters right in the terminal, right in VS Code, using it as an IDE. It does integrate with source control systems, so Git as well as others. But so if you're using GitHub, if you're using Azure DevOps, if you're using Bitbucket or something else, it'll integrate with that. So you can, sync your code down from that Git repository, make your changes and push up and do what you need to do. There are themes, so you can change the look and feel of VS Code. You can actually make it look like other IDEs that you might be used to if you're switching over to VS Code from something like, let's say, Python or Atom or others. You also have some other great features inside of VS Code like breadcrumbs. So as you're navigating, you can see where you were and get back to that. You can open like the Explorer if you're using it on a Windows box. There's an outline view, and there's also workspaces. So workspaces kind of works like projects. So you can create a workspace per a project and then open that workspace, and it'll bring your configuration back, open all your files that you had that you were working on, bring all that stuff back. And there's many, many more features within VS Code, but we're not going to be able to cover all of those here in this course. Now, there are Python extensions that are available for VS Code. There's actually many out there. Some of them are actually built by Microsoft, and some of them are community-based. And so there's a lot of options out there for VS Code from a Python extension perspective. Now let's look at the Python extension for VS Code, and this one was built by Microsoft and maintained by Microsoft. Now, before we get into that though, something that is key for you to note is you have to install Python and you have to install the Python interpreter separately from the Python extension. So if you have VS Code and you load the Python extension, but you actually don't have Python installed on your box, well, you're going to be limited, right? So make sure you go and get the Python interpreter and make sure you have Python installed. Now, the Python extension is basically going to enable Python development within VS Code, and there's a ton of features. So it supports Python 2.7 and above. It supports Python 3.4 and higher, so keep that in mind. It has code completion. It also has code snippets. So you can actually select from snippets of Python code and bring that right into, like, let's say your Python script. And it does have IntelliSense. And so it's going to do that syntax highlighting for you. It's going to call out errors if you have errors in your code. So that's really going to help you. It also has linting to analyze for potential errors. And it supports multiple Python modules for this to help with this, right? So PyLint is listed there, Flake 8, and a few more. So you can choose what you want to use from a Python perspective to support your linting. It has debugging support, and VS Code has debugging in it. So you can do breakpoints, you can walk through your code. It has the full-blown debugging support, and it supports Python. It also has testing, so you can use that to test your Python code. You can do unit tests, or you can use PyTest to support the testing. It also supports virtual environments for your Python code. So it supports Conda, and it also supports venv. Now, what it doesn't do, like opposite of PyCharm, PyCharm has a GUI and makes it really easy to set up a virtual environment for your Python, right? And uses Conda and venv. VS Code doesn't do that. So you're still setting it up kind of through the terminal there, but it does support it, and you can certainly use those virtual environments. It also supports editing for Jupyter environments. So if you're in that data science space, maybe you're running Linux servers, you're also doing some data science, and you need to do both as far as working with Python, it supports that as well. And then it supports PIP, so installing packages and also doing that package management for Python. And this is what I was referring to in the previous slide, is that there are key maps, right? So if you're coming from a different IDE, such as Atom or even PyCharm, or you're used to Vim, you can set up these key maps. That way, what you're used to working with from a keyboard shortcut perspective, and also you can get themes that look like some of these IDEs and add that to your VS Code. So you can kind of have that look and feel. You can have your key maps that you might be used to as you transition over to VS Code. Now, here's a summary of VS Code for Python. So VS Code is free. It's open source. There isn't a paid version. Keep that in mind. Also, you can get started with editing, building, and debugging your Python code really, really easy. There is rich support for Python. So Python's a first-class citizen on VS Code. There's also deep integrations with many other languages. So pretty much any language you could think of, right? From JavaScript to Rust, it's supported within VS Code. And so if you're doing Python, but you're also working in another language, you can use one IDE, which is VS Code, to go ahead and work with those multiple languages. Also, VS Code supports all the major clouds. So working with all the major clouds, Azure, AWS, GCP, and others. And it supports many frameworks. So if you're using Django, if you're using Flask to develop Python web applications, you can do that all in VS Code as well. And it supports many systems. Again, it's available for cross-platform, so no matter what you're working on, pretty much, it's going to support that. So you can install VS Code locally, or you can install it on servers and go ahead and work with it from there with your Python code. Couple of IDEs that we talked about. We're going to look at Python in VS Code and what that experience is like, and then we're going to take a look at PyCharm. Let's dive in. We're going to start off by taking a look at VS Code and the Python experience in VS Code. So we'll go ahead and launch that there, and then I'll just quickly take you through and kind of show you VS Code itself, and then we'll look at some of the Python specifics. So as you can see here, this is like the main window here for editing like code and files. And then down here, you have a terminal and you have some other consoles, and we'll get into those here briefly. And then you have your menus up here where you can, open files and access like the command palette and some other things in VS Code. And again, we're not here to deep dive into VS Code. We're here to look at the Python aspects in VS Code. So a few things that I want to look at first with you is the first thing you're going to want to do is go to extensions. And in extensions, you can actually type in Python, and this will search the VS Code marketplace. And then what you want to do is find the Python extension that you want and install that. Now there's one from Microsoft, and that's the most common one. And if you click on this extension, it'll actually tell you what the extension can do, gives you a description and a bunch of information, right? You could see that I have this installed, but if it wasn't installed, let's say like this Python extension pack, then I could click on install here to go ahead and install that. Now, if we go back here to the Microsoft one, you could see we have a few different options. We could disable this, we could uninstall it here, and there's variety of things we could do with it. You can also see the rating here, and you can see, kind of a walkthrough of how to use this extension. So it's very, very useful. You'll also notice that there was a ton of results that came back when I typed in Python at the top here. So there's a lot of useful Python extensions for VS Code. Take a look through here and choose which ones you want to use. That'll help you with your environment and your sysadministration. Now, there also is this Python extension pack, and this one actually installs other Python extensions. And so this is a really good one to get because it's going to give you the Microsoft Python extension, but it's going to give you these other ones too, like this environment manager, some IntelliCode. There's some things for like Django if you're doing that, as well as this Python indent. So as you're typing your code, it'll automatically indent your code for you to make life a little bit easier. So for now, I'm going to go back here and we'll actually close this extension page. And I just want to show a few more things. So this first icon is the Explorer, and this is where you can open and work with files. And then you have search here for advanced search and replace functionality within your scripts. Here's where you have your source code integration. So I don't have this integrated with anything right now, but if I had it integrated with like GitHub or maybe another source control system, that's where I would do that. Here's my debugging. Again, we just came from the extensions. Because I have the Python extension installed, I have testing here, and I also have Python. So I don't have testing set up, so we're not going to do anything with the testing here today. And with the Python, if you click on that, it'll actually show you your Python environments. It'll show you your different versions, and you could actually expand this to get information, as well as see the different packages that are loaded for your different versions. You can't do a lot of other things with this, but this is really good just to kind of see information about your Python environment. Okay, so very useful there. And then you have some other things like your profile and configuration of Python down there. And so we're not going to get into that because those are VS Code specifics. But there is something I want to show you over here, and this is our Python language that we have selected. Okay, if we click that, we could actually select other languages. So if you're working in like an HTML file and you open a Python file, you could actually change the language down here to Python and start working with that. But when you are working with Python script files in here, you want to make sure that you're on the right language mode, okay? So up here, there's also something called the command palette, and this is important to know. And the command palette gives you access to various options, configurations, features, other commands that you might need access to. And so you could come in here, and if, let's say if you were working with JavaScript, you could actually type that in here. But for the purposes of Python, we typed in Python, and we can see a lot of different options here in Python, right? So we could come in here and we could select like the Python debug Python file, or we could, create a Python terminal. But pretty common ones are up here. You could see that they're in the recently used, but selecting your Python interpreter. So you could see that I could select my different versions here of Python that I wanted to work with. And also take note that there's the virtual environment. I only have one created, and I could actually select that. So if I click that, notice down here that this changed to the virtual environment. And that shows you what environment you're actually working in. And you'll notice I have that virtual environment over here as well. So if I were to click this again, it's actually a shortcut to the select of the interpreter. And I'm just going to go back to the global for now. We're going to come back to the virtual environments in a little bit. So I want to show you some more things from the command palette about Python here. So I want to select my linter, right? We've talked about linting. So we have different linting packages available to support our linting in Python. So you could actually choose whichever one you're familiar with. So I'm going to choose one that I know is not installed on the machine because I want to show you an experience here. And I think that one was actually installed on the machine. So let's try this again. We'll do select linter, and we will do Prospector. So Prospector is not installed. So VS Code is going to prompt me because it sees that and it knows that it's not installed. So I could click install here, and it's actually going to open a Python window and install that for me. So that's one of the nice things about having the Python extension in VS Code. It'll help you out with things like that, right? And so now let's go back here and let's go to Python configure tests. And so this is just to show you, you could select various testing packages to support your testing needs, right? And so now I'm set on PyTest, and again, VS Code saw that I didn't have that installed, so it went ahead and ran the install of that for me to make things easier for me when I need to do my testing. All right, now let's talk about the terminal here. So you can see that I'm in Bash, right? You can see that there. And so I can go into the Python interpreter by typing in Python 3. And now I'm in the Python interpreter. Now let me exit this. And I also could go into IPython right from here. And you can see that I'm now in IPython. Okay, let me go ahead and exit this. Also, you can actually launch additional shells right from here. So I could have a different Bash shell, and then I could go into my Python interpreter here, and then I could actually launch another one. And in this one, I could go into IPython. Okay, and then I could move between them. And I could actually split this as well if I wanted to see side by side. And so let's go into IPython with this one. And so now I have IPython here, and I have, my standard interpreter over here. So let's close these out just to clean this up. And then so that just shows you one way to get into the various interpreters for Python right through the terminal here. Now let's take a look at these scripts, and let's run these scripts and kind of work with Python here. So all right, so we can actually take and run this code right from here, and we can select, run in the terminal. We can also run it in a Python terminal. So let's run it right here. And so that opened up Python for us and ran that. So we can do that with our other script here too. And so you can see that. And so it's running that in the Python interpreter within the terminal. So it's just a clean way to do that. And also notice that I'm still able to run my bash shell commands that I might need to run, right? So it makes it very, very easy there. Also, you could take this code and I could run it from an interactive window. And so this is actually part of the Jupyter extension, but this is really cool and super helpful. Kind of gives you an interface to work with right inside of VS Code when you're working with Python code. So let's close that one and we'll just show you what it looks like running the other script here that way. So pretty cool there that you have those two options available. So let's shift gears here and let's look at debugging with this script. So let's shift gears here and let's actually look at debugging with one of our scripts. So we have another script here. We have the user age script, and you'll notice that I have an error right here. You'll also notice that I have a breakpoint set right here. Okay, so keep those things in mind as we're going to run through this script. So let me just run this in a couple of different ways here. So we'll run this here. And so it's prompting me for this, and we'll just say I'm 29. So it's giving me an error, right? It did output the results, but it's giving me an error. And let's run this in an interactive window just so you can see that as well. And so notice that VS Code, it prompts me up here for my age. And then it gave me the results, but it's also giving me an error. So I already know what the error is because I've staged this, and you can see it here. But let's say for the demo purposes that maybe we didn't know what was going on. Maybe we had a much larger script and we needed to figure that out. What we would do is we would go into debugging. So we're going to come over here and we're going to go ahead and click Run Debug. And so notice that it changed the menu over here and it's running through our file. And also notice that it stopped right here on the script because I have a breakpoint. So I could continue through this breakpoint by clicking the step into, and then it prompts me down here for my age. And so I'm just going to give it that. And we'll just continue to step through. So this is a good way where you could troubleshoot your script. And it's showing me that I have an exception here and time is not defined. Right? And then if I go all the way through, it's going to show me that error. So I know that, okay, that's an issue in my code. I need to define time. So let me uncomment the import time at the top. And that should actually do it for us. And so now let's actually remove the breakpoint and we'll click the play over here to work through our code again. And what's our age now? We'll say we are 37. and it's telling me I'm an adult and it's running the sleep code, right? So super useful having the debug inside of VS Code here. Okay, the last thing I want to show is working with virtual environments. So let's go back over here, and we know that we have this PyCourse 1, right? This is a virtual environment. Let's go ahead and create a second one. So let's clear the screen here. Actually, I want to close this debug console. And let me go just back to Bash here. And so what I want to do is I'm going to create a PyCourse 2 virtual environment. So we'll create that. And you'll notice it created it over here. And it's prompting me asking if we want to use that for the workspace. We'll just say yes here. And it's also telling me I'm missing a linter, so we'll just let that install. Just for the sake of it, it's doing it in a different window or a terminal window there, so we don't mind. But now we have this PyCourse 2, and we also have PyCourse 1. And so with this PyCourse 2, and you can see that we have that selected there with this PyCourse 2, let's open the containing folder. And so you can see this is where all my scripts are stored. You can also see that I have my virtual environment for PyCourse 1 as well as for PyCourse 2. So let's actually navigate into the PyCourse 2. And let's create a new file. Let's call it hello.py. Keep it simple. And so you can see that created there. And now we can open this and we'll just do a print hello. Right? Really basic. And then now I want to go ahead and run this. And it works. And if we open our other virtual environment, you can see that it doesn't exist there, right? The other thing I want to show here about the virtual environments is if we expand the lib folder, we have psutil loaded in PyCourse 1's virtual environment. If we expand the PyCourse 2, we have different packages loaded, but we don't have the psutil. Right, so that's where you can get into doing isolation between the virtual environments. So that brings us to the end of this demo. I know that was quick. There's a lot to cover. We could have covered more, but that should be a good way to kind of get you started with VS Code. And next, we'll look at PyCharm. Let's get started with our second demo. Now in this demo, we're going to take a tour of a couple of IDEs that we talked about. We're going to look at Python in VS Code and what that experience is like. And then we're going to take a look at PyCharm. Let's dive in. Okay, now we're going to take a brief tour of PyCharm. So let's go ahead and open it up here. And notice that I have the community edition installed. So it's the completely free edition. So this brings me to the first screen, and this is where you can basically load a new project in your PyCharm. You can see that I have a couple projects here. Before I go there, I want to show you, if you want to learn more about PyCharm kind of on your own, you can install it and then you can launch it and go to Learn PyCharm. And there's a lot of great resources here just to dive deeper into PyCharm, as we're only going to be able to give you a brief tour of it here to kind of get you started and get you going. So I want to show you what a new project looks like here. So as we clicked on that, right, it gives us the option to create a new project here. So we'll just do PyCourse 2. And take note here, we can select the virtual environments. We have Conda, we have our VNV, and we have some others here. We could select those and it'll actually create a folder for us. and we could choose our version of Python that we want to have with this specific project, right, in our virtual environment. Also take note that you could inherit like global packages. You could also make settings in here available to all projects. And so we'll go ahead and create this just for the sake of it to show you what this looks like. And so this just opened up to a new project. It created this main.py, this Python script file here, just as an example to kind of get you started. And then it has the folder opened up here, and you could start to navigate through this. You could create Python scripts right in here and open them up here in the center pane and start to work with them. So I'm actually going to, we'll see if we can open a different project. And what we'll do here is we'll close this one out. And that gives us the option to come back to the welcome screen, and we're going to go into the PyCourse 1. So you can see here I have some other scripts already open that we also used in VS Code. So we're going to explore them here. But let's take a look through the console here of PyCharm a little bit. So down here you'll notice your Python 3.9. This is our interpreter. So we could actually choose our interpreter here. We could change between versions. We could add a new interpreter, and we could, work with some interpreter settings. And so if you come in here with the interpreter settings, you can do things like change the version, add a new interpreter, or if you have other ones, you could select it in here. And also you could go ahead and start loading packages. Now there's multiple ways that you can go ahead and do this, but this is just one of the ways, right? So I could select the package I want. So if I were to just scroll around in here, pick the package I was looking for, I could click on install here, and it would actually install the package for me. So it does it right through the user interface. You just have some other things in here, like you could change the appearance. You could change the key map if you wanted to make this IDE look like another one that maybe you're used to working with. Your build and execution, some of your tooling, advanced settings. So there's a lot you can do in there as far as configuring your interpreter. I want us to focus down here, kind of in the lower pane, and notice that we have multiple tabs down here. So we have services. We're not doing anything with that, but we have our terminal here. So this is just a standard terminal. You can run all your bash commands. You could also enter into a Python interpreter by typing Python in here, or even IPython if you have problems in your code, right? So the script that you have selected up here, if it has problems, it's going to show it down here. We have our Python console. So this just opens right up to Python REPL/interpreter, and you can start to work with it from there. We also have our to-do. So if we had items that we added on a to-do to follow up and work on, we could work on those there. And then also here's another place where you can access the Python packages, and you could actually install them. So we could click here and install from version control or the disk, or we could expand PyPy here and kind of scroll through, and then we could actually choose one of the packages, and the documentation will actually show up here. Now you can click on install to install a package, and it'll go ahead and install that Python package for you. It's actually pretty cool. And once it's done, you can actually expand the installed, and you can see that package that you installed. It'll bring you back to the documentation here in this window, and you could do things like delete that package. So that's just going to uninstall that package, right, from your environment here. So let's see if we can find psutil. It's a pretty common one, and it's good for administration. So you could see, the documentation there. You could go through and kind of gain a better understanding there. And when you're ready, you could go ahead and install it. Now, you could select a different version. Maybe you needed an older version. You could go ahead and grab that and install it. So we're just going to leave it on latest, and we'll go ahead and let that install. And again, if we expand this here, it shows psutil. Okay. Now, here's your version control. So if we were using version control, which we're not going to do in this example, you could configure it here. You could set it up, and then you could also access it right from there. So let's just pop back over to terminal here and just notice that you have some different things on the menu over here. You have bookmarks, you have your structure, and then you also have your project up here. So we have all of that. So now let's look up here and let's actually start to work with our script. So I want to show you something real quick as far as like the auto indentation for our Python code and the auto completion. There's some really cool stuff here. If we just type else here, notice I typed else and I did not put the colon here. It sees that and it knows that it's expecting that, right? So then I'm going to just do a print here. And notice it's giving me a flyout with the code because it knows what I'm trying to do. So I could double click on that or I could hit enter and then it's just giving me some code there. And then I could do this just to complete that code. If I go ahead and enter that in, the colon, notice how it brought that all the way back to the far right, okay? And it's giving me some other errors here. I'm actually going to delete this code. I'm not going to run it like that, but I just wanted to show you the auto completion as well as the indentation that this PyCharm offers you to help with your Python script writing. Now also you have what's called the gutter over here, and notice you can actually add breakpoints to your scripts just by clicking here, and you could click on it to take it off. So if you have a breakpoint, and let's go ahead and just we'll add one right here. Okay. So if you have a breakpoint and then you decide, hey, I'm gonna go ahead and debug, right? You could actually right click on the file here, or you could select debug here and you can go ahead and run the debug. So the breakpoint is going to stop the code where you have that breakpoint. So if we were to play through it, we're going to stop and rerun it. It's going to stop right at the breakpoint. And let's go back to our file here. And then if you want to toggle this breakpoint on or off, you could certainly do that. And it'll just run through your code. It's very similar to what we saw in VS Code, right? From a debug perspective. So let's move on from that and let's just clean up our code a little bit here. So we'll get rid of that. Now let's run this. So I just want to show you what this looks like running this. There's a couple of ways you could do it. You could just say run from here. You could execute the selection in the Python console. You could run the file in the Python console. If you run it from here, it's just going to run it in the terminal. And so you have different options there for actually running this. So we're going to try this. And there it is. It's running in the Python console. So it changed it over to that down here. And I'm just going to put my age in here. And then it gives us output, but it also throws an error. And the reason it's throwing an error is because we have that line commented out. So we'll uncomment that. And then if we were to run this again, and let's try to execute this in a different way. We'll say run file in Python console. Okay. So there it is. It's prompted me. And this time we'll tell it we're 20 years old. And then it says we're an adult and there's no error. So super useful. So that wraps it up for the tour of PyCharm. Again, I didn't cover everything. This was a brief overview just to kind of show you how it works. You can see that there's a lot of built-in functionality for Python to make life easier for anyone working with Python in this IDE. And again, this was a brief tour. So if you want to learn more, just go out there to PyCharm's documentation and start to dive in deeper and get the community edition, load it up, and start to work with it, on your own. Let's recap what we learned in this module. In this module, we covered the following. We looked at what's involved in setting up a Python environment. We then looked at what the Python interpreters are, and we closed out by taking a look at the various IDEs that are available for Python and what would work well for you. Why is all of this important? It's because setting up your environment for Python and understanding the interpreters and what the right IDE is for you is going to set you up for long-term success. using Python for your system administration. Welcome to the Interacting with the Linux System module. In this module, you're going to learn the core Python and Linux interactions and what that looks like. The first topic area that we're going to cover is how to install Python on Linux. And then we'll dive into some core Python modules that you will want to know about when you dive into your Linux administration. The first one is the OS module, and then we'll look at the platform module. We'll explore the socket module and the psutil module. After that, we're going to dive into the core Python and Linux interactions in some other various areas, such as working with dates and times in Python, parsers and arguments with Python and Linux, and working with file-like objects and streams with Python and Linux. Let's go ahead and get started. Look at installing Python on Linux. So we can do this in 3 steps. And the first step is you want to go out to python.org and check the downloads page to make sure you're getting the latest version of Python. The second step is you'll want to open a terminal on your Linux server and you'll want to run the syntax to actually install Python. So here we're going to run sudo apt-get install Python and our version number, depending on the version that we went out to the downloads page and we got. The third step is you'll want to verify that Python is there and it's running on your machine. So from within the same terminal on your Linux server, go ahead and run Python and your version number. Now take note that depending on the version that you downloaded and that you installed, you're going to need to change the version from what I'm showing here. Another thing to note is that this syntax is based on Ubuntu. And so you might have a different flavor of Linux and you'll need to check python.org just to make sure that you have the specific syntax for that flavor of Linux. What I'm referring to specifically is in step 2, I'm running sudo apt-get install, and that's specific for Ubuntu. Next up, we're going to dive into the core Python modules for Linux administration. Now, we're going to talk about a lot of great modules that you're going to want to have in your tool belt as you're administering your Linux servers. But take note that there's many more modules out there for Python, and there might be some that you might find useful to put in your tool belt to help you with your administration. Now, we're just going to cover some of the really core ones that you're going to want to know about and that you will end up using. Let's get started. So the first module I want to talk about is the OS module. And this module provides you a way to interact with your operating system. It's a great module to put in your tool belt, and it's going to help you work with the OS, directories, files, and more. To use this module, you're basically going to put import space OS at the beginning of your Python scripts. It's pretty simple. That means this is one of the standard Python modules that come. That means this is one of the standard modules that comes with Python that's already included. Now, here's some syntax of what you could do with the OS module. We have os.getCDW. We have os.getCWD. Now this is going to print your working directory. If you think back to when we were talking about the Python interpreter, once we're in Python, we don't have the ability to just run pwd like we do in the shell. And so this is where the OS module can help to start to fill some of those gaps and do much more. So let's look at some more examples of using the OS module. So the first example here is using the OS module to actually create a directory. So we have os.mkdir and then the name of our directory. Now, what this is going to do is it's just going to create that directory in whatever path that you're in. And then you can start to create files in there and start to work with the directory. And then the next example is basically list dir. So this is going to list the contents of the directory that you're currently in. So if you're thinking back to doing this from the shell, you could typically run ls. Well, we don't have that capability in Python's interpreter by default. And so again, we can use the OS module to get us that functionality back. And then the last one here is just we're using the OS module to basically rename a text file. So something else that's very common that you'll need to do right through your administration or while you're something that's very common that you will need to do while you're administering your servers. And so This is basically renaming a file named file.txt to myfile.txt. So pretty straightforward, but very, very useful. The next module I want to talk about is called the platform module. And what the platform module does is it basically gives you a way to interact with your underlying platform on your servers. Now, again, this is a standard module with Python that comes default, and it's very, very useful to have in your tool belt, just like the OS module. Now, with this module, you can get information about the hardware. You can also get OS information about your different nodes, and even some information about Python, like your Python version, right? And to use the platform module, you basically just put import platform at the beginning of your Python script. Now, here's an example of being able to get the Python version using the platform module. Let's look at some more examples here. Now, we're using the platform module to get some information about our machine. So we're using the platform.machine method. And what this is going to do is it's going to tell us if our machine is basically 32-bit or 64-bit. In our next example here, we're using the platform.system method, and this is going to return whether our operating system is Linux, Windows, or something else. And then the last one here is the platform.node method, and this is actually going to return the name of our server. And so you can see where that could be very useful as well. Now, the next module we want to talk about is the socket module. And this is basically going to give us a low-level networking interface so we can interact with the networking on our servers. Now, this is another module that's a part of the standard library that just comes out of the box with Python. And this module basically gives us access to a lot of functions, objects, and things that we need to perform network tasks that are common in administration. And to use the socket module, again, you're just going to do an import space socket at the beginning of your Python script. Now, here's an example of using the socket module to get the name of your server. And yes, we can also do that with the platform module. So that's a good example where there is some overlap between the modules, and you will just end up using whatever module seems to work best for you. So now let's look at some examples, right, of using the socket module. So the first one here is just, pulling back the server name of our server. The second example is creating a server socket. And the last example is binding that socket that we created to an IP address and a port. So you can see there, we're binding the socket to the loopback address of our server on port 8080. And then we're telling the socket to go ahead and listen for connections. So we did the server side. Now I'm showing you an example of creating the socket on the client side so we can actually communicate with the server socket. So this syntax will create that client socket. And then the next example is actually connecting to that server socket. So you could see the syntax for that right there as well. And also take note that we're using the host name, right, versus the loopback address. The next module I want to talk about is the psutil module. This is a cross-platform module, so works across Linux, works across Windows, and basically anywhere you can run Python. And this basically gives you a way to access processes and system information. This is a great module that you're going to want to have in your tool belt, and it can help with system monitoring, system profiling, working with processes, looking at your process usage, and also management of your processes on your servers. Now, to utilize the psutil module, you actually have to install this. This is a module that doesn't come as a part of the standard Python library. So you need to use pip to install it, and there's the syntax there for installing this on Ubuntu. So you would run sudo pip install psutil. After you do that, then you can put your import space psutil in your Python script, and you're ready to go and start using psutil. Now here's an example of being able to print out your CPU times on your server. Really helpful, right? Now in the first example here, we have the print of our CPU times using psutil, and that's what the output would look like. Now we can use psutil also to print out our disk usage on our server, and that's the example of what that would look like. So you could see how much disk space is being used up, what do you have left, etc., etc. And in our last example here, we're using psutil to actually tell us what our boot time is of our server. So we could see if it's fast, if it's slow, has it changed since the last time we looked at it. So you can see that psutil is pretty useful, and there's a lot more that you can actually do with it. So now I'm showing you an example of a script that is a server health script, and it's utilizing some of the modules that we just talked about, as well as some others. But let's kind of walk through this. And by the way, we're going to do a demo of this. You'll see this script live, and we'll talk a little bit more about it there as well. But let's walk through it right now. So at the top on the left, you could see that we're importing psutil, our OS module, platform, and we're also using socket. You also could see that we're also importing some additional Python modules like time, call, and something called pretty table. And then as we move down in the script, you can see that we're fetching information about our network, about our memory, and this isn't showing the full script, but when you see the full script, we're fetching information about our disk usage and much more. Now here's an example of the output of the script. And again, you're going to see this in the demo, so don't worry. But this is just to give you an example. So you can see the formatting here is nice and clean and easy to read. We're doing that by using the pretty table Python module. And so you can see where we can start to bring in lots of modules that are out there for Python to help us accomplish what we want to accomplish. But that pretty table is helping us to kind of put these sections together and put them in a nice readable format. And you can see that we're pulling back information about our network, our memory, our disk usage, and even our processes. And we're using various modules to do that. We couldn't just import the OS module and get, information about processes, right? We need to import psutil to help us get that information. And so being able to mix and match in the scripts in Python is very useful. And so that wraps up this section. Next, we're going to go ahead and look at a demo of this server health script. Now we're going to take some time and look at a demo of running the server health script on our Linux server. Let's go ahead and dive right in. Now I'm on my Linux server and I have VS Code open and I have my server health.py Python script open, and we're just going to take a look at this script and then we're going to run it to see what it looks like. So you can see here at the top of my script, I'm importing several modules. Many of these we've already talked about. And so you can see psutil, you could see platform, OS, you could see socket. You could also see time here, and you can also see pretty table here. And so I'm just running through in the script. I'm looping through here. I'm printing a nice little banner here at the top. And then I have different sections. And you can also see that in VS Code, it doesn't like my indentation, but my script still runs and it works just fine. But in this first section, I'm gathering the operating system information, right? And you can see that I'm mixing and matching modules here to do that. So I'm using the OS module there. I'm using the platform module there. I'm even using socket down here, right? And then I'm printing the output here. And then as we go down, I'm kind of doing the same thing in network, but I'm only using the psutil as far as to gather the information that I need there. And then down here, I'm using psutil again to gather my memory information that I want to have in my script output. And then as I scroll down, here's my disk information. So you can see I'm using psutil again there. And then I'm just using pretty table throughout the script to format. And you could just kind of see, here's our processes, here's our CPU count and more CPU. And then that's the end of the script. Now let's see this in action. So we're going to go ahead and run this and we'll check it out here. And we'll stop it right there. So if I didn't stop it, it would just loop through over and over and over so it can collect the most up-to-date information. I also could take this and I could output this output here into a file if I wanted to record that, like let's say on a daily basis. But let's explore what we have here. So here's our operating system information. So it's just telling me the type. It's telling me if it's Linux. If I ran this on a Windows server, it'd say Windows there. It's telling me the version, my architecture. So this is a 64-bit machine. Here's my server name. And here's the IP of my server. It's giving me my network status, my memory usage here. So my total memory, how much is used, what's available. Same thing with disk, right? So these are common things that you need to know around your servers to understand how they're doing. And then my top 10 processes and what's using up my resources on my machine. So pretty useful here as far as the script. And this is just an example of being able to use multiple different modules that are available for Python to accomplish administrative tasks. Let's go ahead and work through and explore core Python and Linux interactions now. And the first one we're going to look at is working with date and times in Python. Now there's a module called datetime in Python, and this is one of the batteries included modules, meaning that it's included with Python when you install it. Now in order to use this in your Python scripts or even in the Python interpreter, you just do a import space datetime. Now, with the datetime module, you have classes, and those are used to help you work with date and time, right? In things like log files or text files or scripts or whatever you might need in regards to working with the date or the time, right? And these classes have a number of functions and methods that you can use for working with dates and times and even time intervals. And let's explore some of these classes. So these are the most common datetime module classes here that you'll probably end up working with. And so the first one is date, and this is based on the Gregorian calendar with the following attributes of year, month, and day. And then we have time, which assumes that you have exactly the same 24 hours in every day, following the attributes of hour, minute, second, and microsecond. And then we have date time, which is a combination of both your date and your time, and it has the attributes of year, month, day, hour, minute, second, microsecond, and TZ info. And then we have something called time delta, which is basically the duration between either two date instances or two time instances or two date time instances. Now let's look at some code examples here. So in this first example, we're actually using the combination of the date time class with a function of now, and we're printing that out, and that's actually going to give us the date and time of right now. And so we could use this in a Python script, or maybe we're writing log files, and we want to record that point in time and that date of when maybe a specific event occurred. Now, the next example is we're using today's date, right? And we're placing that in a date object, and then we're printing that out. And so that's just going to give us whatever date it is for that point in time. And then in the last example here, we are using the datetime module, but we're importing just time, and then we're creating a variable, and we're putting the time in that variable, and then we're going to go ahead and print that out. And so that'll give us that specific time. So you can see that. So we might want to use that, right, if we're scheduling something, or if we just want to write a time into a file, for example. And so these are some examples of using the datetime module that comes with Python. Next, we're going to talk about command line parsers and arguments in your Python scripts. So there's a module that's not one of the batteries included with Python, so you have to install it separately. It's called argparse. Now, this is used for parsing command line options, arguments, and subcommands. Note that argparse replaces some older Python modules named getOpt and optparse. Now, if you're using an older version of Python, or you still need to use those modules for whatever reason, they are out there. But typically, we're using argparse going forward, and that's where, new enhancements and everything is going into this argparse module. Now, let's take a look at some of the characteristics of argparse and what you can do with it. So it allows the use of positional arguments, and we'll explore that. It allows the customization of prefix characters. It supports variable numbers of parameters for a single option, and it supports subcommands. So let's take a look at argparse, like how to install it and what it looks like in a script. So to install it, you have to run pip install argparse. And then to use it in your scripts, you just use the import argparse. Now, we're going to build out a Greet Python script here, and we'll show you what this looks like using argparse. So, of course, we want to have our import argparse at the beginning of the script, and then we go ahead and create the parser, okay? And then we'll go ahead and add whatever arguments we want that are going to be a part of our script. So in this argument, in this example here, we are adding an argument of name. We're telling it that it is a string, and we are requiring it to be there. So if you were to run this script without this argument, it's going to error out on you. Now, we want to add the parse for the arguments. So we do that here with this syntax. And then we're going to go ahead and add a print to the end of our script. Okay. So let's see what this looks like in the output. So if we run this as, our Python 3, our greet py script, and I'm adding the argument that we've specified as required in our script with my name, it's simply going to print hi Steve. Now, if I were to run greet.py without that name argument, then it's going to error out on us. Now, let's take a look at some other examples of arguments for argparse. So in this first example, right, we're using the name argument again with a type string and required true. So this is from the previous example. Just wanted to make sure we pull this up again so you can compare. Now, for the second example, we're actually specifying a type of integer, and we're asking for age. And so if you were to run the script with the name argument and the age argument in the script, you could specify the name and the age. Now, take note that we didn't specify the age is required, so it's actually optional. Now, in this next example, we're also putting in an argument for another integer, but on this one, we're requiring it to be true. And then on the last example here, we are actually adding an argument of values, and this is a type of integer, and we have the end args there equals 3. So what this will essentially do is it's going to look for 3 values, and then it's going to add them together and give you the sum. Now let's talk about working with file-like objects and streams in Python. Let's first set the stage. So Python can provide us with file-like objects that represent the standard in, standard out, and standard error. It does this using the sys module. And remember, the sys module comes with Python when you install it, so it's a part of the batteries included. You may be asking yourself, what are the standard in, standard out, and standard error? What does that mean? Well, let's break it down. So the standard in stands for input, and it's basically used for taking input into the stream from somewhere. Could be from a user, could be from a system, could be from some sort of files, etc. Now, the standard out stands for standard output, and it's basically used for sending data to the output of the stream. Now, we're taking data in through this std in, and we're sending data out through the std out. And those are both happening across the stream. And then we have our standard error, which is std error. And basically this stands for standard error. And this is going to be invoked when you have a command that has an error, and it's going to store the error message in the stream. Now, standard in, standard out, and standard error are not Python specific. These are in Linux, the operating system. And so there's a stream that's in the operating system. Now, Python knows how to work with these using the sys module. Let's break this down even farther. So our standard in, standard error, and standard out are all data streams. And basically with data streams, you can transfer data from a source to an outflow and vice versa. And with streams, you can basically read text from a file, and you can write text into a file. Now that's breaking it down into very simple terms. Now, we can take that and go from a system to a system, for example. And if we look at the graphic there, we have our standard in, let's say that's coming from some sort of file, and we're processing data in the stream. And if there's no errors, it's just going to go into the output, which is our standard out. And in our example there, let's say that's going into a log file. When the standard in comes in, if there's some sort of error that occurs, then it's not going to send it to the standard out. It's going to send it to the standard error. Now, streams in Linux are treated as if they were files. And so when we're utilizing the standard in, standard out, and standard error streams in Python, they're being treated as if they're files as well. Now let's look at this in a script. So we have a stream test Python script here. Okay, we're importing the sys module, we're looping through our input, and then we're sending our data to the standard out or the standard error. Let's take a look at this in action. So in the terminal, we're catting some sort of file that has data in it. That's our input. We're piping that to our stream test Python script, and that's either going to output to an outlog or an error log file. Now, what this looks like is we have our import of our sys module, and then we're looping through the standard input, and then it's going to go through and process through the Python script, and it's either going to send it to that standard out, which is going to go to that outlog file, or if there's an error that occurs, it's going to send it to the error.log file via the standard error. And so it's pretty straightforward, but that should give you a visual of how Python can work with file-like objects and streams using the sys module and the standard in, standard out, and standard error. Let's recap what we learned in this module. So we covered the following. We looked at how to install Python on Linux. We also took a journey into some core Python modules, such as the OS module, the platform module, the PSUtil module, and more. And these are important to know as you dive into your Linux administration utilizing Python. And then we looked at working with dates and times, parsers, file-like objects, and streams using Python. Why is all of this important? It's because knowing the various ways that you can install Python on the various Linux flavors is going to be important, because most environments don't just have one flavor of Linux. And it's also good to understand the core Python modules that are going to help you along your way when you're administering your Linux servers. And so you'll want to have those core modules in your tool belt. And then also, it's critical to know how Python can work with things like date and time, parsers, streams, and more. So thanks for joining me in this module. We'll see you in the next one. In this module, using Python with files, strings, and text in Linux, we're going to cover some core concepts and methods in Python that you are going to want to be familiar with when you're administering your Linux servers with Python. Let's go ahead and dive into the topics we're going to cover. So we're going to talk about string literals and operators, and then we'll talk about various methods that you can use when working with data and files. And then we'll cover what functions and tuples are. And then we'll talk about how to open and close files. We'll talk about how you can read binary files with Python. And then we'll wrap up with an intro to the difference between strings and bytes in regards to Python. Let's take some time now and explore string literals and operators within Python. So a single quotation mark or a double quotation mark can represent a string literal in our Python code. Let's take a look at what this looks like. So we have a word there between single quotation marks, and we also have the same thing in between double quotation marks. So if we put that in our Python code, Python's going to know how to interpret both and know that that represents a string literal. Now, for operators, these are used to perform various operations on variables and values within our Python code. And here's an example of some of the operators that are available in Python. Now, this doesn't include all of them, but this is a good sampling here. So we can add, we can subtract, we could multiply, divide. We could say this value is equal to this value or is not equal to this value. We could do a greater than, less than, and much more. Now let's see an example of this. So the first example there is if we wanted to add 10 and 5 together and have that print to the console, we could do that using the print there, 10 plus 5. In the second example, we're saying print something if the first value is not equal to the second value. Now, this section has a long title, and what these represent are the various methods that we're going to look at as far as what you can use with Python to work with your files and text. So the first one we're going to talk about is formatting. Now, you can use the format method, right, to combine strings and numbers in Python code. Now, if we look at the code above, we're doing my intro. And what we want to do is we want to print out my name with my age as a part of my intro, right? And so we're creating a variable with my age in there, and we're creating a my intro variable with my name. And then we use the print method to go ahead and print this out to the console, or maybe we have a UI. And so we're using the format method there to represent my age. And you can see in the output that it combines the string and the number to represent what I want. Now, the next one here is the split method. And we use this to split a string into a list of strings. And so we could see here in the first variable, we have a list of numbers 1 through 5. And we want to go ahead and take the split method and go ahead and split those up. And you can see in the output that we've done that. We've split these up into a list of strings, and there we could take that data and like put that into a CSV file or some other system, or output it to something else and use it as a list versus one string. Now with joining, that's the join method, and that is the exact opposite of the split method. And so we use the join method to go ahead and take a list of values and combine that into a string. And if we look at the code there, what we have is my first and last name in a list, and we can go ahead and join those into a single string, right? And you can see that using the join method. And you can see the output there where it's my first name underscore my last name. Now, note that I used the underscore in this example, but I could have used a comma, or I could have used just a dash to represent in between the two values there. And the next one here is the find, and this will be used all the time as you want to look for, data, maybe in files, or maybe in variables, etc. Right? And so the find method is used to find a substring within a string. And if that substring is not there, then it's going to return a value of -1. Just an FYI, so you know about that. Now, in this example, we're looking for the word octopus in our quote there. And so we're using the find method to look for that. And the output it's going to give us is the position of that word octopus. And so there's many use cases for this to help you look through, let's say, log files or other types of data to find something you're looking for specifically. And then you could use this in a script to execute some other set of logic against the value that you find, right? The last one here, the last method we're going to look at is replace. Now, you'll probably use this frequently as well. So you can replace text in a variable, or maybe even in a file, or some sort of data with text that you want to replace it with. And so you can see here, we have a variable of my text, and then I have another variable with the replace method where we are replacing is with was. And then I'm printing my variable out to the screen using the variable that has the replace method in it. And so I've replaced is with was, and you can see that represented in the output there. Next up are functions and tuples. Now, we're not going to dive deep into these, but it's very important for you to understand what functions are and what tuples are. So functions are a block of code that is run when it's called. And so we can define a function, and within a function is a block of code. And once that's defined, later on in our code, or maybe even from other scripts, we can call that function and it will execute that code. And so there's many times where you will need to run the same block of code over and over and over. And instead of having to type that out every single time, you can just put that into a function and call when needed. The other thing you can do with functions is you can pass parameters to functions. And so you could execute a block of code while passing a parameter to that function. And so you could see in my code here, I've defined a function, and in my function, I'm just printing out some text. And then when I call the function, it's going to print out the text on the screen. Now, tuples are used to store data, and they're storing multiple items of data in a single variable. Now, it's important to know about tuples that once you define them, the data is ordered, it's unchangeable, and it does allow duplicate values in the list. Now let's talk about opening and closing files with Python. This is critical because this is something you're going to need to do on a regular basis. So we can use the open method to actually open files, and we can look at the code there. So I've specified my file, right? And I'm using the open method to open a text file. I'm also passing a W parameter, and what the W parameter does is it tells Python that I'm opening this in write mode. Now there are several different options for modes when you're opening files, and we'll look at another one here in just a second. Now, when I open that file, I want to write some content to that file, so I'm using the myinfofile.write, and then I'm putting the content that I want to write to that file in parentheses there, and so I'm writing my content into that file. Now, when we have files open, we need to go ahead and close them properly. And to do that, we're going to use the close method. And so you can see that I've opened my info.txt file, but I'm passing the R parameter this time. And that's representing that I'm opening this file in read-only mode. And then I'm using a print to go ahead and print the contents of this myinfo.txt file to my console. And then when I'm done with that, I'm going to use the close method to go ahead and close out that file. We just talked about the difference between strings and byte objects. Now let's talk about reading binary files. And this is going to help close the loop on why we talked about strings and byte objects. So that's a representation of a binary file, aka a byte object. And so all you see are zeros and ones. This is in machine readable format, not human readable format, right? So it'd be really hard to understand what this data represents. And that's what binary files are. They're a sequence of bytes that you can't read as a human, but the computer understands them. Now, often binary files are used by computer programs, and they're often used for executable purposes. For example, you might have .bin files, or you might have .exe files, right? Now, the content of a binary file is interpreted by a program, aka a bin file can be executed in a program, or an exe file can be executed in a program. So the program understands that binary file, or binary files might be used by like a hardware processor, and they basically understand the format. Now, when a binary file is required to read or transfer from one location to another, the file's content is encoded into human readable format. Now, that might be a binary file that's not executable, but it could be something like a archive file, right? A .tar or gzip or even a .zip. Now, what if you want to read from a file that isn't text, right? Like a .tar file. Well, if you try to open that up and you don't have a compression program on your machine, it's going to error out. And if you try to open that same file in Python, it's going to error out. And that's because something like a tar file, or maybe even an image file with an image format that is not supported on your server, you don't have the computer program that understands the format of that file, it's not going to open up. It's just going to error out on you. Now, Python does have tools for working with binary files. And so we can actually open binary files using the open method. And what we do there is we pass the B parameter when we open the binary file. And so we can also specify the R parameter to specify that it's in reading mode. Now, when we use the B, we're specifying that it's a binary file, but we're also telling it not to use any decoding. And here's what the code actually looks like for opening a binary file using that open method. We specify the actual file in our variable. We put in our parameters, whatever they might be, and then we can go ahead and use print to output the contents of that binary file on our console or our screen. Let's talk about the difference between strings and byte objects. So first of all, strings are a sequence of characters. They are in human readable format, so you can understand what the strings are. They need encoding before you can actually store them on disk. And examples of strings might be text, images, or audio. And there's some representation of some of the types of files for strings. So it could be in PNG format, JPEG, MP3, or simply just text files. Now, byte objects are immutable sequences of bytes that are integers in the range of 0 to 255. Now, byte objects are in machine readable format. So you can open a binary file and you won't be able to tell what the data is because it's in zeros and ones. Now, bytes can be directly stored on disk. Let's recap what we covered in this module. We covered the following. We looked at string literals and operators. We looked at various methods for working with text and files, such as formatting, splitting, joining, finding, and being able to replace. And then we gained an understanding of functions and tuples. We learned how to open and close files using Python. And we also learned how to read binary files with Python. And we looked at the difference between strings and byte objects. Now, why is all of this important? It's because in Linux administration, you work with text and files all the time. And so when you're using Python for your Linux administration, you need to know how to use Python to work with text and files as well. And so this is going to serve you along your journey in your Linux administration with Python. Welcome to the last module in this course. This module is titled Combining Python with Other Tools. In this module, we're going to cover some core concepts around using Python with some of the Linux tooling as well as other tooling to help enhance your Linux administration experience. Now let's take a look at the specific topic areas that we're going to cover in this module. So first, we're going to talk about the Python standard library versus third-party libraries and really help you understand what the differences are here between these two. And then we're going to look at the top 10 Python tools for Linux administrators that are out there. And we'll look at using Python's logging framework. And we'll take a look at creating and reading tar archives with Python. And finally, we'll wrap it up by looking at how we can run Python scripts on a schedule using cron in Linux. Let's get started. We're going to go ahead and compare the Python standard library versus third-party libraries. So the Python standard library basically translates to modules that don't need to be downloaded or installed after you've installed Python. This translates to batteries included because these modules come with Python. Now there's over 200 plus of these core modules that come with Python as soon as you install it. And any library that's listed in Python's core documentation is a part of the standard library. And I've listed the URL there for Python 3. So you'll need to make sure if you're out on the Python documentation that you're looking at the correct version for your Python. Now, modules in the standard library don't need to be installed, like I said before, they simply need to be imported. And some examples of these modules are the sys and the socket modules. Now, for Python third-party libraries, you can discover third-party modules in the Python package index, also referred to as PyPy. This is the official index for third-party Python modules. Now, you also can go out to like GitHub and you'll find modules out there, and you can certainly use those as well. But the PyPy index is going to be the best place for you to go to discover third-party modules for any needs you might have in Python. Now, these do need to be installed, and you can install them using pip. So you would run pip space install space the name of the module to go ahead and install them. And then after you've done that, then you can run the import space module name in your Python script or just in the interpreter. A couple of examples of third-party modules that you need to install that are very common are NumPy and psutil. Let's take some time now and talk about the top 10 Python tools for Linux administrators. Now I'm going to cover some Python modules as well as some Python tools themselves. Let's dive in. So the first one I want to call out is psutil. We covered that earlier in this course, and it's a really great tool to have in your tool belt because it helps you work with the underlying hardware and operating system of your servers. And then you have the OS module, which is good for working with the operating operating system. And then you have something called Click. And what Click does is it's great for helping you to create command line interfaces quickly and efficiently, and working with those command line interfaces so that you can speed up your scripting when you're doing your administration. And then you have Salt. Now, Salt isn't a module for Python. It's actually a full-blown infrastructure as code platform, but it's built on Python. And so if you're familiar with Python, you'll have a leg up when you go to learn Salt, and it's really great for your administration, so I included it. And then we have Requests. So this is great for working with web servers, and basically it allows you to send HTTP requests right through Python. And so that's your first step in like troubleshooting if you're working with web applications or web servers. And then we have Ansible. Again, Ansible is not a module like these other ones. It's a full infrastructure as code platform, kind of like Salt, but it was built on Python just like Salt. And so it's very, very useful. And if you understand Python, you can pick up Ansible pretty quick and use it to help with your administration. Now, the next one is called 2 to 3. And what 2 to 3 does is it helps you migrate your Python 2 scripts into Python 3. And so this is very handy and very useful if you have Python 2 scripts that you need to go ahead and upgrade to work with Python 3. And then we have the Sys module. And the Sys module, we talked about this earlier in this course, is really great for working with general administrative tasks on your servers and your operating systems. And then we have the platform module, and similar scenario there. It's very great to help you work with your operating system, your servers, and even at the hardware level, and even some tasks that you might want to administer in Python itself. And then we have the Socket module, and this is great for automating network tasks across your servers. And that wraps up the top 10 Python tools for Linux administrators. Let's explore one of the most important aspects of using Python for Linux administration. We're going to look at logging. So the logging framework in Python is basically powered by a module called logging. This is a built-in module, so it's batteries included, and it provides the framework that you need for emitting log messages from Python to your programs. Now, the logging module is often used by developers, and it's often utilized in many libraries. It also is the go-to in regards to logging for Python system administration. Now, to use it, you simply type import space logging in your scripts. You don't need to go through a pip install for this one. It's included. Now let's look at what the logging module can do in Python. We can use it to emit logs to various destinations. Some of these are the terminal, syslog, or systemd. We can use it to create custom log messages with timestamps. We can define the severity of our log messages. We can format our logs to meet specific requirements. And we can report error suppression without throwing an exception, for example, to the end user. We also can use it to capture the source of log messages. Now, Python's logging framework consists of these following components. Handlers is the first one, and what handlers does is sends the logs created by loggers to a destination. And common handlers are file handler. So with that one, you would be sending the log messages to a file. Stream handler, and you would be sending that to a stream such as standard out or standard error. Syslog handler, so you're sending that to a syslog daemon, or even HTTP handler, and you're sending those log messages to HTTP. The next one is loggers. Now this is exposing an interface that your Python code can use to log messages. And then we have log record, and these are instances that get created automatically by the logger module whenever something is logged. And then we have filters. Filters provide a mechanism to determine what logs actually get recorded. And then we have formatters that determine the format of log messages. So if you have some sort of custom format, this is going to go ahead and handle that for you. Now let's look at Python's logging framework flow. So first off, the logger exposes several logging methods to app code at runtime. And so you need to have the right logging method, right? When you're running a script or even running logging as a part of an application. And number two, the logger determines what log messages to act upon based on the logging level. And we'll talk about the logging levels in just a second here. Third up is that the logger passes along the relevant log messages to the interested handlers. And we just talked about the various handlers. And then the handler that takes it will dispatch the appropriate log messages. And finally, the formatter is going to format the app log for any specific behavior that's needed or specific formatting that's needed. Now, here are the logging levels. Now, something that's important to note is that when you set the log level, you're basically telling Python where you want the logs to start from. So, for example, if you set the logging level at warning, it's going to include warning, error, and critical, but info, debug, and not set will not be included. Now, take a second to look at the different logging levels, and you can also look at what they're used for. And so it's important to just become familiar with these so that you understand what sort of logging level you need to put in your logs. Now, let's look at some logging code. So again, we're importing our logging module and we're running our logging level at warning. And this is basically going to capture any warnings that come out of, let's say, a script that we run, and it's going to print that to the console. And then we have logging.info, and so that's a different logging level, and that won't actually print anything. Now, this is an example of logging into a file. And so in this code, we're importing our logging module, and then we have logging.basicconfig. And basicconfig is a method that's used to configure various settings for our logging. So you can see we're setting the level there to info, and then we're specifying a file name, and we're also specifying the encoding. And so when this runs as a part of our code, it's going to go ahead and put the logging into that mylog1.log file. So that wraps up logging in Python and the framework and the logging module and how this works. There is more to it, and it's going to vary depending on what you're doing with scripting or if you're writing actual applications that you're using as a part of your system administration, or maybe you're doing something else with Python. So you could actually spend more time digging into the logging aspect for your specific needs, but I wanted to at least touch base on this and give you a foundation for logging when it comes to Python. Let's talk about another important aspect of administering your Linux servers with Python, and that is being able to work with tar files. What is a tar file? It basically stands for tape archive files, and these are basically compressed files that have many files inside of them, and they're used to compress the size down for storage or easier portability. And so when you compress these files down into a single file, typically you want to uncompress them at some point so you can use or view the content inside of these tar files. Now with Python, it has something called the tar file module. And this tar file module is included with Python, so you don't have to do a separate install. And this tar file module makes it possible so you can go ahead and read and or create tar archives. You can use it with gzip, bz2, isma, and other formats, but you can't use it with .zip files. .zip files are typically used on Windows servers, and if you are working on Windows servers with zip files, you can use something called the zip file module for Python. Now, tarfile has a number of methods, and let's explore those. The first one here is the open method. And this is basically just taking the tar file's name as an argument, and it will open the tar file. The second one is tar file, and this one needs a file name and a mode parameter. Okay, and then you have the add file method, and you can use this to add an object to a tar archive. And you also have the add method And you can use this to add an object or objects to a tar archive. And you have the extract all, and what this will do is extract all of the objects that are in a tar archive into either your current path if you don't specify a path, or a specified path. And you also have extract, and you can use this to extract specific objects from a tar archive. And again, if you don't specify a path, it's going to go into the current path. Now let's take a look at some code and examples of using tar file. Now in this example, we're extracting a file using the tar file module. So at the beginning of our code, we're importing tar file. Again, we don't need to install it separately like using pip. And then we go ahead and we specify our file name here, and that's our tar file. So you can see tutorial.tar. And then we're going to go ahead and open that tar file in read mode. So that's important to note. And then once we have that open, we're going to go ahead and extract a file out of it. And the file we're extracting is the sample.txt file. And we'll run a print command there. And then we'll run print file.read, and it will print the contents of that file on the screen for us. Now we don't need to print the file. We can do something else with the file after extracted. But in this example, we're printing the file on the screen. Now, when we're done, we'll go ahead and use the close method to close the file out. Now, here's another example. And in this example, we're creating a tar file using the tar file module. So again, we're importing tar file at the beginning of our code, either in a script or in the Python interpreter. And then we're specifying the file name for our new tar file. So we're calling this myfiles.tar. And then we're going to go ahead and use the open method with tar file. And we're going to open our new file in write mode. So you'll notice the W there, as opposed to the previous code, we opened it in read mode. And then we're using the add method to go ahead and add 3 files to our new tar file. So the plain.xml, sample.txt, and person.ini. When we're done with that, our code is going to use the close method to go ahead and close the file out. And so that wraps up at a high level using the tar file module in Python, what it is, and giving some examples on how to work with it. Now let's explore another important aspect of administering your Linux servers with Python, and that's being able to run Python scripts on a schedule using Linux cron. Now, what is cron? Cron is a tool that's built into Linux, the operating system, and it lets users basically run scripts, commands, or software automatically on a specified schedule. There's something in cron called crontab, and this is a file that lists the jobs that cron will be executing. It's also important to note that cron doesn't run when a server is asleep. So you need to make sure that your servers are running during the times that you want to run your Python scripts. Let's look at the steps of running Python scripts using cron. So the first step is you will create your Python script that you want to be executed, and then you'll create a crontab file containing the cron schedule that you want to run. And then you'll go ahead and create a Python script scheduler using the cron parameters. And there's 5 of those. And then the script will go ahead and run on your server and perform whatever actions needed, or you'll see the output that is the output of the script. So let's dive a little bit deeper into scheduling a task with cron in Linux. Cron uses schedule expressions to know when you want to execute a task. And this expression has 5 parameters that you could choose from to tell cron when to run your script. And these are minute, hour, day of the month, and day of the week. Now, you could configure those parameters manually, or you could use a tool called crontab.guru. And this is a free tool that's out there that exists. It's just a web app, and it's really easy to use and simplifies the process for you. Now, I'm out here on the crontab guru website, and I just wanted to give you a glimpse into how this tool works. So I have 5/4, and I could put in 27 here. That's the day of the month that I want to use. And then here I could could put in 11 just for an example, and that'll give us November. So this is actually telling us what these parameters represent to make it easier for us to know what's happening here. And we can go through and change these to our need and to our liking, and then we can specify that in our cron tab file. So this website just makes it a lot easier to go ahead and work with the parameters that go into the cron tab. Now let's look at an example of executing a Python script via cron tab. So in here, this python-script.py will execute at 4:05 a.m. on the 27th of every November. We've specified all of that using the 5 parameters there of 5, 4, 27, and 11. So it's pretty straightforward. And that wraps up our overview of using Python scripts and cron together to. Let's recap what we learned in this module. In this module, we covered the following. We took a look at the difference between the standard library and third-party Python libraries. And then we looked at 10 core Python tools that could be used for Linux administration. We took a journey into logging within Python and what that framework looks like. And then we looked at how we can use Python to work with tar archives. And then we finished it up by looking at using cron to go ahead and schedule Python scripts within Linux. Now, why is all of this important? It's because when you start to administer Linux using Python, it's important to know what other tools can be combined with Python to help you perform your system tasks, such as cron, tar, and even the logging framework. Thanks for joining me during this course. I hope you got a lot from it, and good luck on your journey with Python.